क्या बोल रहे हो? हाँ। सो हेलो एवरीवन, गुड मॉर्निंग। मेरी आवाज आ रही है? एम आई ऑडिबल?
Yes.
ओके मैम, जस्ट वेट फॉर
Yes, sir.
5 minutes. 35 people have joined. Meanwhile, if anyone has some doubt, they can share or they can speak.
I have a request till the time participants join. Can we have a quick review of that what we have covered yesterday? Like just in words, not to explain it. I
Okay,
don't need to
okay,
explain it. Just
okay. Yesterday, we एक minute. हाँ. Yesterday actually we tried working with single band imagery, which is digital elevation model. So what we did, कि uh, we searched for the data by the name digital elevation model, and then we imported that DEM. Then we have selected the band from that DEM. We have created a variable by the name elevation. Then selected the band in which we want to work upon. Then we have added that layer to our map. Using this map.add layer, we tried to add the digital elevation model in our map. And then we hello. Am I audible ना? मेरी आवाज आ रही ना?
Yes, sir.
Okay,
Yes, sir.
Yes, sir.
okay,
Clearly audible.
okay. Thank you. So after that, we also tried to change the visualization using the setting button from the layer panel. Like we use this layer panel setting button and we tried to stretch our image. We stretched through percentage stretching as well as sigma stretching. Then we also tried by creating some palette to our DEM. And then finally what we did ki we clipped our DEM to our area of interest. तो इसको यूज करके अपने we drew one polygon here and then we tried to
Sir,
clip that area.
I have one query. In this
Yes,
code, you have mentioned clip time is equal to elevation. Uh,
yes. Dot clip AOI.
huh. Does it require to mention here elevation directly? Can we use clip within bracket AOI and then semicolon?
No. Actually, this dot clip should get some image. Na, ki we need. This is very important because this clip will tell ki you have to clip this thing, the elevation band. This elevation information is stored in this part. Na, it is stored in this variable. So clip will not know ki to whom I have to clip, which image
Okay,
I need to
okay,
clip. So that's why that image name has to be given. Whenever you do in GIS also, na, there are two things that you provide. One is the input shapefile,
right,
and the other thing is the raster image which you want to clip out. In
right.
the QGIS that we do, similar thing here is like we are giving one image and we are clipping using this shapefile.
Okay.
Okay, इसलिए both are required.
Then you have mentioned map dot add layer clip dem.
Yes,
Then you are assigning dem clip NASA. Is it required within one quoted comma? This single quoted
हाँ
comma?
हाँ. This is just for the layer name. See, first of all, see this clipping part will be stored in this variable clipdem. So we have mentioned that layer to be added. So this layer was added at the bottom. Then we have
Okay.
provided the visualization parameter, which is this one.
Okay.
And then we have given the layer name, like what name you want to view it here.
Already it was assigned DAME Global NASA earlier.
No, this was for that. This was for the global DEM. This
Okay,
ELE in this
entire
map.add layer, we have mentioned global NASA. So that was for the bottom one. But
entire
the
world. That is for
uh,
entire world.
that was for the entire world. So I have written DEM global. Whatever
Okay.
you will write here, na, that will be shown in the name of this layer. I can only
Okay.
write DEM clip and then run. That means ki DEM clip will be shown here. It is
Okay.
only for the reference ki your this layer has this name.
Newly created layer name you are assigning, that means.
Yes. I'm just assigning the name to the newly created layer.
Okay. Okay.
Yes. Then what we did, we then uploaded our shapefile here using this asset new and shapefile option. And then we try to import our shapefile by the name table. and then we rename that name of the table with our AOI, so that the DEM of our area of interest or our shapefile is seen. And the last step that we did, like we tried to export the DEM which was created. So this was all that we did yesterday. Now today we will be learning how we can work with image collection.
Sir, hello.
Yes, yes.
Sir, another participants are unmuted. That's why some noise are created. Please ask him
Okay,
to. Please,
I
sir.
will try to. Okay, actually, this right is not given to me. I will ask. भाई आवाज किससे आ रही है? अखिलेश सर नहीं, कौन अभी कौन बोल रहा था ये? ऋत्विक है।
Ridvik.
ओके ओके, अरुण सर की भी out. Actually ना मुझे वो actually this whole meeting is been taken care of by our headquarter team, so it is very difficult for me to mute anyone. Everyone please mute your mic. I request everyone to please mute your mic. Ritwik sir, please mute your mic. और कौन है? ऋत्विक सर प्लीज म्यूट योर माइक. कहीं आवाज आ रहा है ऋत्विक ना. Exported time and open in QGIS, the elevation values are different. We have to manually assign the value and the color ramp. Elevation value should not be different. Like, what do you mean by different, Swapnil? See, the dam which we export will have its actual decibel elevation value. And we have to, you don't need to assign any value in your GIS software. That will GIS software will automatically take the minimum, maximum, mean, and all that part. That needs not to be defined. When we are working in Earth Engine, during the visualization, we need to mention the minimum, maximum in order to improve our visualization. But in QGIS, that is not required. You can directly start working with the DEM which you have exported. And color ramp needs to be defined again in your GIS. So yesterday I have shared a code for the snow cover mapping. ऋत्विक सर को कॉल लगा देता हूँ. Just hang with us. Great. इसको इसको थोड़ा फोन लगा दो. 966 966
Understand.
मेरा है ना इनका कर लगा दो कॉल लगा oh sorry 9666971263 मोटरोला का I I request everyone to please mute your mics. Namratan. Fine. So I believe everyone has gone through this code which I have shared. This snow cover mapping code. Sir, can you please share the link again? Okay, I will be sharing this. It is already shared in the group. I am sharing in the chat box now. वेट हम एक काम करते हैं कुछ चीजें इसमें इम्प्लीमेंट है इसकी जरूरत नहीं है तो
व्हाट्सएप में भी शेयर
हाँ वहाँ भी किया था कोई बात नहीं I have shared the code again. Please open in your everyone please open this link which I have shared in the group. When this page will open, then type yes, it is done. Everyone should be on the same page.
Done, sir.
Done. Yes, yes. Okay, fine.
This slash is used for description. double
Ah,
slash.
yes. This double slash is for commenting like that. This line will not be executed, so you can use it for giving any description to your code.
Instruction. Okay.
You can even write your own, like this is for centering to your shape file. So
Okay.
depending whatever you understand from this code, you try to use double slash and try to write so that it will be easier for you to remember in the later stage. So this comment is used to to give comments to your code, or and this line will not be executed. In the line in green color will not be executed. So I've written what this code is all about. This code is about snow cover mapping using NDSI. So the first step what I did, I created a random shapefile over my area, over this discrete area of Ladakh. I have just created a random shapefile using this geometry import toolbox, which was discussed yesterday. We have to click on this box and then I have selected an area. Okay. Later you can change it with your shapefile also if that has some snow cover. Then otherwise, I have just taken a random shapefile of in a shape of a box. Then what I did, this line number 8. This is also a kind of very important line which we generally use to bring our map to our region of interest. Like by default, when you will open the Earth Engine code, your map will be shown in the US like this. When you will open the whenever you open the Google Earth Engine for the first time, it will be shown here. But this map.center object, which takes the input as an image or it could be a shapefile. So I have taken my region of interest as my centering object, and this 8 is my zoom scale. So whenever I will run this much part, I'm just commenting all the part. Whenever I will run this part, what it will do, it will bring the screen. It will bring my shapefile at the center of the screen. Just by running this thing, only this line, what this will do, map.center object will bring the base map, this UI map at the center of my shapefile. Okay, so whatever, so this will be used to generally locate your shapefile. Suppose your shapefile is somewhere else here. So whenever I will run it, it will bring my shapefile at the center of the map. Okay. Now the next line, which is very important, we are now working with. I hope you all have gone through this code yesterday only. So I will try to explain what each line means. So now what I have created a variable by the name S2. F2 is the short form I have written for Sentinel-2. Because I am working with Sentinel-2, so I have written F2. You can take any variable name. So I have taken F2. Inside this, we all know the Sentinel. When I will search it here, Sentinel-2. So I have taken this level 2 SR dataset, surface reflective dataset I have taken. So if you will click on import, you will see it comes by the name image collection, because this is not a single day imagery. It is an imagery for multiple days starting from, if you will click here, you will get to know it starts from 2017 March onwards, 28 March onwards. And in order to get it from the server of Google Cloud, we use this EE.image collection. And inside this, the name is Copernicus S2 underscore SR underscore harmonized. So there was some error in the Sentinel satellite tracking, so which they have already corrected, and now they are producing all the harmonized image. So there was some overlapping issue was there, which occurred I think last year it occurred. So now they have updated the code and then they have produced a Copernicus Sentinel-2 SR harmonized. So the collection name is Copernicus F2 SR harmonized. So what I was saying, I have created a variable and I am calling the Sentinel-2 imagery. So this was the snippet. So I copied it from the snippet and I have written it here. Now there are some inbuilt function which are used to filter my data to my region of interest. because you all know कि sentinel imagery covers the whole global area. Okay, and it is available from 2017 March onwards. But we want the snow cover for a particular date, for a particular region, and for a particular cloud cover. So what we have did, we have added some filtering algorithm. So these are some filtering algorithm. The first filtering algorithm is filter bounds. Filter in small and B in capital, filter bounds. Inside this, we provide our boundary or we provide our region of interest. So this box is our ROI. So what this filter bound does, it brings all the sentinel imagery which are near to my area of interest. If I will just add this map.add layer S2, you will see ki all the sentinel imagery. If I will don't write this if I don't write this filter bound, then the sentinel imagery for whole world will appear. It will take some time because there are a lot of imageries at 10-meter resolution, and for the global area, it will take a lot of time to even retrieve from the server. You will see my player has just started, but it will take a lot of time in order to produce the image for whole of the world, depending upon my internet speed and server speed, everything. It will take a lot of time. But in order to reduce the imagery to our region of interest, we are using this filter bound. So what this will do, it will bring all the imageries which are near to which passes through my region of interest. It could be, all the images will be mosaic, and it will come which are near to my area of interest. See, it will take some time because I have not given the filter of date. So all the imageries which are passing through my area of interest, it will try to generate. See, but I don't want for the world, so I only want which are the bands which are the path which is around to my shape file. It has given. Okay, this filter bound will filter the imagery which are near to my area. Now the next filter is filter date. What this is doing, this is again reducing the image to my particular date of interest. So I wanted, either you can give in single inverted comma or you can give in double inverted comma. Both will work fine. But the format to give date is year, month and day. Year, month and day. And this first day will be counted, while the second day will not be counted. So this means ki this will bring all the sentinel imagery which are available from 1st October 2022 up to 14 October 2022. This last day is not counted. Okay. So if you will run this code and use inspector and click anywhere, then you will see in the series part, there are total 3 imagery. One is for 1 October, 6 October and 11 October for my area of interest. Okay, there are total 3 imagery. When we had not done this part, filter date part, when we have not done, at that time, all the images from 2017 to 2024 will come, or up to 2025 also. Like if you will check the date, the last date is, it is till date. I think it is available. It is available up to 4 June. Like for today also it has updated. So you will see there are 476 images. If I don't put the filter date value, and you can see all the value of band information time series is there. But I don't want this much date range, so I have given this filter date, so that the whole list has reduced to only 3 dates. If I click anywhere, you will see at that value there are total 3 images. Then the next filter we can even use, which is by the name cloudy pixel percentage. What it is doing? It is, first we have to write the method is like we write dot filter, then we write double E filter dot LT. LT means less than. Now this less than function, what it does, it takes the information from the metadata. Then when the metadata name which stores the information of cloud is cloudy pixel percentage. So we give the name and separated by how much pixel percentage you allow. So I've given the pixel percentage. Suppose I can give ki I want those images only which are having cloud cover less than 10. And how to know ki what is the name of the metadata that is storing the information of cloud? For this, you have to click on this image and go to the image property option. And there you will see ki this cloudy pixel percentage stores the information of cloud pixel percentage taken from the original metadata. Okay, so this is the name of that band which we are using for filtering for the cloud. Now when I will run, it brings me
Sir.
only single image. Yes.
Sir, I
Too
have
much
seen
noise is
some.
Hello.
Yes, sir.
too much noise is coming, sir.
अच्छा, noise is coming. Okay, किसका आ रहा है? एक मिनट. Let me check.
कोई डॉक्टर पीसी चनियाल है सर.
PC चैनल है ना.
Hello.
Chanial sir, please mute your mic. Okay, fine. Okay. So my screen share. Okay. The screen visible है ना? So now you can see when we applied this cloud cover filter, my image has reduced to only single image. That means this is the image. If you will look into, it has this is the image which has the cloud cover less than 10%.
Sir.
Huh?
Sir, I have
Yes.
seen some scripts where instead of the cloud pixel percentage, they have used cloud cover. So both are
Yes.
same. Or...
Okay. That cloud cover metadata is having with Landsat imagery. And this cloudy pixel percentage stores the information of cloud with sentinel imagery. Like if you will search here Landsat imagery, in Landsat, suppose Landsat 8, you will check here in Landsat 8, the image property is cloud cover, which stores the information of percentage cloud cover. Okay.
Okay, sir.
So when we have to filter for the Landsat imagery, there we have to use cloud cover. But since we are working with Sentinel-2 imagery, we have to use cloudy pixel percentage. Okay.
Okay, sir.
Okay. So this line is used to filter for the cloud. Okay. So now our image is ready. Now the next part is I have just printed this part also. Like to this print S2 will give me all the metadata information. Like for this range, how many data sets are there around my region? So there are total 8 imagery. One is for 3rd June, 2 are for 3 June, 4 are for 6 June, and 2 are for 8 June. So using just by simply writing this print f2 will give me all the information of the metadata, and you can even click on single image and check their property. Everything, how much cloud cover they are having, how much cloudy pixel percentage is there, and what is their band value. All the metadata information, solar irradiance for every band, they have calculated. Water vapor percentage, water percentage, everything is there. Just by simply writing print this collection S2, it will give me the information of all the images which are generated, which are inside my around my region of interest. Okay, so there are total 8 images which are around my region of interest. So this Earth Engine automatically does the mosaicing part. Okay. Now comes key, my region is not appearing very good. So it is appearing in black color. So I need to improve the visualization. For that, we have to repeat the same process. We will turn on setting. And now we know that this is a multi-band imagery. It is not a single band imagery. So we will use this 3-band combination of RGB. And we must know ki before that ki what is the name of each band. Like what does which band range each band is working. So B1 is for aerosol band. B2 is the blue. B3 is green. B4 is red. 5, 6, 7 are red edge. Then 8, 1 is NIR. Then 8A is red edge, B9 is water vapor, B11 and B12 are sphere 1 and sphere 2. Okay. So all this band information, we can get it simply by clicking on this link and clicking on the band. So now if we want to do the natural color composite, so can anyone tell what combination I should use here?
RGB.
RGB.
For RGB, which band should I use here? I have to pass this thing with R, this thing with G, and this thing with B. So B1 should be
B3.
4. It should be 4 because 4th band is my natural red. Then 3 and then 2. Okay. And also I have to give some stretching so that my visualization is proper. And then I will click on apply. Four, 3, 2. Say ये आ गया. Okay. Red, green and blue. Fine. So this is the visualization which is appearing. We can even increase the gamma if you want to make the image more lighter. So this is my Sentinel natural color composite, and it is coming in brownish color because that area is a bit barren land. The area which I have selected is a bit barren land. It is near Ladakh. So it is appearing like this. Okay. Now can anyone tell if I want to do the false color composite, then what combination I should use? Here.
It will be 8, 4, 3.
Yes, very good. It will be 8, 4 and 3. So I can just simply change the band combination here and will get the false color composite. And you could see there are no red or very less red color are shown because the trees are very less in those areas. In the areas of Ladakh, we have very less amount of trees. If we have shifted this thing, suppose towards Uttarakhand, like in suppose Himachal or Uttarakhand, if we have shifted the same combination, then you could have seen this was the black color. Oh, sorry. If I will take 8, 4, and 3, give some stretching and gamma, you will see we have a very good visualization of the sentinel band around our area of interest. Oh, sorry. And one band is missing because that cloud cover part might be not there. 10%. So these are the images which are for that date, which are having cloud cover less than 8, 4, and 3. Okay. Okay. So like this, our visualization can be done. And now if I like this visualization, I can simply import this visualization and it will come by the name image with param here. And that I can use like we were using it yesterday. After this map.add layer image with param, then we can even give the name S2 FCC. And running the code will give me this. So the visualization method is same like we did yesterday. The only thing is we have to now provide the band combination. Rest everything was covered yesterday. And palette is only given when there is a single band imagery. In a multiple band imagery, we don't provide palettes. We give the band combination only. And this band combination could be changed according to your need. Like if you want sphere band, also we can give B 8 and 3 as a combination. And you will see the snow will appear in cyan color. Clouds will be white only. Snow will appear in cyan color and the vegetation will appear in green. This combination is 11, 8 and 3. This 11 band sphere band is used to differentiate snow with the clouds. So like this, just changing the band combination, we can visualize where in our area, where are the snow and where are the clouds and where are the water. This is Tehri Reservoir. Then this is Alaknanda Basin and this one is, I think, this is Bhagirathi Basin. Bhagirathi River Basin. So like this, you can change the image visualization parameter. I have imported this green color also by the name images param2, which I am using here. So now whenever I will run this code, the combination of this will be there. Green for vegetation, cyan for snow, and white for cloud, black for water. Now comes the next part, we need to calculate the NDSI. So to calculate NDSI, I have created a function by the name S2 NDSI. I just given a variable name S2 NDSI, that means Sentinel-2 NDSI, which is equal to a function. Now this variable will contain a function. So whenever we define a function, we pass some variable inside this and then we give us curly bracket. And inside this curly bracket, we define all the function component. And every function should return something. That means it should print something or it should do something. So we are returning image.addBands NDSI. And what this NDSI is, we have created a new variable by the name NDSI. And then what we are doing, whatever image that gets passed through this function, there is an inbuilt function by the name normalized difference. I hope everyone knows the meaning of normalized difference. Everyone
Sir, I
knows
am
that?
having one query.
Yes.
Yes, yes,
Variable S2 NDSI is equal to
yes,
function. Why we are using function here directly? Can we use this image dot normalized difference
yes. We can
without
directly
using?
use also image dot not normalized difference B3, B11, but we are using function because this image, this function will work on single image. It will not work on the whole image collection. And since we want कि जितने भी images, we have total 8 images and we want all the 8 images should, in all those 8 images, this function should be there. Okay, so that's why we have created a function. Otherwise, we have to create a single band imagery from this image collection by typing dot median या dot mosaic or dot mean. And then we can do the single hand formula, dot normalized difference. But here is, if we want to generate the time series of NDSI, we have generated a function. Okay.
If possible, could you please add a brief description after each code using double slash earlier as you have
Okay.
mentioned? So this will
Okay.
help everyone to understand
Okay.
later on
Okay.
when they will
Okay.
be using.
Okay. We have created a function to calculate NDSI for every images. So this function is created to generate the NDSI for every images. I have tried to give some description, but not in very
Sir,
detail.
later on, you can use
Okay,
these
okay, fine,
description
fine.
before sending us this code. After each code, if you mention using double slash, then it will be easier for.
Okay.
Okay. Thank you,
Okay.
sir.
I will incorporate your suggestion. That is very
Okay.
good suggestion. I will
Yes, sir.
surely try to add the comment. So this normalized difference means it will do this formula. It will take the first band, whichever we are giving, that band minus the second band divided by this band plus the second band. And this normalized difference is a image enhancement technique which takes the maximum difference of the spectral reflectance. I assume that you are having some background of remote sensing and you know what is the meaning of spectral reflectance. So we take the difference where there is maximum reflectance and the minimum reflectance. So in the case of snow, we take the value of 3 and 11 because they have in this difference has the maximum value of the spectral reflectance. And this formula will be applied and green minus sphere will take the difference. So it will have the maximum value and dividing with the same ratio. This is called ratioing. What this will do, dividing this function will remove the shadow effect. Like if some of your region is having is in the hilly area and it is towards the leeward side of the mountain. So that shadow effect is generally removed when we divide with the DN value. So this NDSI generally works with the principle of taking the maximum difference and dividing with the sum. और sum से divide करेंगे, that means it will never be zero. So this thing will work every time. This will work. Similarly, if you want to do for NDVI, we take NIR and R. So at that time, the band combination should be taken accordingly. Since we are working with snow cover estimation, it is very much very easily estimated using green and SWIR band. So we have taken green minus SWIR. And for Sentinel, the SWIR band is band 11 and green band is band number 3. And what we are doing, we are also, after applying this formula, we are also renaming the name of that band, so that a new band is created by the name NDSI. Apart from these, all the band which that image has, that band 1, band 2, band 3, a new band will be there by the name NDSI. So this whole line is creating a new band with the name NDSI, and that new band will have this formula B3 minus B11 upon B3 plus B11. And what are we are returning? We are adding that band. Original image is having the band from B1 to B12, and we are again adding a band by the function add bands, and this variable, this NDSI variable, which has the name of this capital NDSI. So one more band will be added, and that will contain the value of NDSI. So this function will do all this part. Now we need to pass all our images which is stored in this S2 image collection. We need to pass through this function. So for that part, we take one inbuilt function by the name dot map. So this dot map, what it does, it takes a list. It takes a list of images, which is S2. S2 has the list of images, and it maps. That means it is like a for loop. Like it will loop through every images, and it will loop all the function. This function I have passed inside this map. So every image which is present in this S2 will go through this function, and that formula is created, and for every image a new band is added by the name NDSI. So when I will add this NDSI collection, and since I have only selected the band of NDSI, so now you will see when I will run this code, this Sentinel-2 NDSI collection. So this will be a single band imagery because we have only selected the NDSI band. We have selected the NDSI band, and this is the NDSI imagery of the whole collection. Since how you know it is for the whole collection? Because if I use this inspector button, you will see a time series of. My list is small. If I increase the range, then you will get to know. If I'll take the inspector and check, there are total 10 images, and you can see all the band combination is there, and NDSI time series is also generated. NDSI time series is also generated. If I'll click on some snow part, then you will see the high NDSI are there in the snow. So since I'm using dot map function, we are able to generate the time series also. At any single point, we can generate the time series of that NDSI. See, in this NDSI collection, I will hide this part. See, it is giving me the value of this mean NDSI, and if I take on this series, see all that date, like this is for October 3, then October 28, October 23, November 2, November 12, November 17, all those images with their NDSI value, I can simply get by clicking on a single band. Because we have created a function, that's why we were able to generate the time series. If we have not created this function, only single image we can get the value of NDSI. That part we are going to do the next. Now next time what I have created a median imagery. Like instead of collection, I want key for this whole date from 10 to 12. There are total 10 images, but I want a median of this 10 images must be created. For this, I will use a function dot median. So what I am doing, I am giving the variable NDSI dot median. What this will do, this will take for every pixel, it will calculate the median of 10 images. Okay, and then it will create a single imagery. From that, I am selecting the NDSI, and what I am doing, dot clip ROI.
Sir, why we are not taking mean?
Why?
Why we are not taking mean instead of median?
Because you see, median, when you will see the value of DN value, you can even take the mean. It is not there is no issue. But what median does, it removes the very darker pixel and also removes the very brighter pixel, and it takes the median value which has the optimum pixel value. When you will take the mean, what it will do, it will even take the darker pixel also and brighter pixel also, and it will calculate the mean. It will take all the value and then calculate the mean. But taking median will only take that pixel whose values are lying in the optimized type. It is not very darker and not very lighter. Like higher DN value means lighter pixel and lesser DN value means darker pixel. Na? So in order to reduce that
Yes,
part,
yes, sir.
we generally take median. But even you want to generate the time series of mean NDSI, that is well. You have to just type dot mean and click anywhere on the pixel, and your NDSI time series of mean will be printed. You can take anything. You can take minimum also. You can take maximum also. So dot mean, minimum, maximum, and median all are supported. Okay. From there we are selecting the NDSI band because you want to generate for NDSI. And this clip function, you remember this clip function will only work on the single imagery, single band imagery. Clip function will not work on this image collection. If you will type here clip, it will not work because clip function, if you will check the syntax, it clips an image to a geometry or feature. It never clips an image collection. Okay, so we have to use dot clip only after either creating mean, median or something. Then only we can go for our clipping.
If we
And
have to
now if
mask out multiple images, then what syntax we can use or what code?
you can reduce the date range. You can reduce the date range. Best thing is that if you reduce the date range so that minimum pixels are there, or matlab only those imageries are there which you are interested. Or you can do do the cloud filter, उससे थोड़ा कम हो जाएगा.
Okay.
Okay, so that if you want to reduce the images, you can better is to reduce the date range so that minimum images are there for your area of it. Otherwise, what this will do, this will take all the 10 imageries. If you will check these 10 imageries, they are total 37 imageries all over the region, all over my area of interest. And it will create a mean of those imageries. And then it is giving me the NDSI. If you will reduce the date range, then your number
It
of
means
images will reduce. That result will be more appropriate because it will be for your month of October only. Otherwise,
it
it will
means
take the
engine on engine we can mask out only single imagery, not collection, image collection, or multispectral data can't be masked out. Masking
please
cannot be
repeat.
done. Masking cannot be done on engine, on image collection.
Masking means clipping.
Clipping, right.
Yes,
Clipping.
yes. Clipping. This clip function only supports single imagery. You can do for the multiple imagery if you create a function. Like if I write this inside this, inside my function. If I write dot clip, because dot clip inside my function, I am passing the single image. If I will do this, my clipped image will only come. See, clip image only works with single imagery. If I take it inside the function, then I can do with the multiple images. Okay, now I'm mapping. See the difference. If I took it inside this function, then it is taking every single image every time that image, this formula is calculated, and then it is clipping. So my imagery, the outside part is removed, only the images which are inside my polygon are shown. So we can use here only clip. This clip function को अगर collection से के साथ clip करना है, then we need to give it inside a function. That's why creating function was very important in our work. Single image, when you will write with single image, you will face a lot of difficulty. It is better practice to create a function. Lot of problem gets solved by creating a function. Okay. That's right. Clip. So I have taken median, you can take mean depending upon you. So now it is not clipped, but this part is clipped. Okay. Now this part I have already commented for you all, which I will be discussing a bit later. The second part is now the next part comes ki how we can differentiate the area. That now our task is, since we have created NDSI, now I want ki my NDSI image should convert it into two band. One will give me snow and other is non-snow. That means I want to classify my image into snow and non-snow. For this, we will use some threshold value. So can anyone tell what is the best threshold that is suggested to differentiate snow in NDSI? Can anyone tell the value of that NDSI which differentiates NDSI, which can differentiate snow?
That's greater than 0.5, sir.
Very good, very good, very good. It's around 0.45, 0.32, 0.45. Someone said 0.4. Very good. This is the actually that this paper was published, which says ki approximate range should be in this range 0.3 to 0.4. I think by Kulkarni sir only has shown that value. But actual value varies for every images. For every image, the threshold value varies. It is not like 0.4 will give you the exact value of snow and non-snow. It varies for every pixel. And that value is estimated through the bimodal histogram. So you need to first create a histogram of that image and then you check by which value it is differentiating from snow to non-snow. Suppose I have written here 0.4. Taking your suggestion, I have taken the value as 0.4 and it has differentiated snow. It is fine. It has differentiated snow with cloud. Comment, double comment means comment only. Like 2 times comment I have written because if I will just type once, it will not go. It will still remain. Because this was previously commented, I have again commented. So that's why 2 times slash has occurred. So by this line, what I'm doing, I'm again creating a function. I am passing each image and now I'm writing greater than 0.4 and then dot self mask. What this function does, it will only keep that images which has NDSI value greater than 0.4 and remain everything it will mask out. That's why we use this dot self mask function. It will take all the image. It will take the value of NDSI greater than 0.4 only and rest it will mask it out. So dot self mask is used to mask out the remaining part. And I am renaming it as snow cover. So my new function in which I have named the name. Acha, see, here I have not created any variable. Like function can be declared without any variable also. Like you can simply declare a function and later on you can apply a variable and apply that function. Like function, previously we were creating a variable f equal to something and then we were passing f. So either you can do this or you can simply either you can pass this f dot map and then write that function name. So it is better you can even remove this function, just type this function name and in a variable, new variable, you just give the name of that function, apply threshold, and inside this I am passing this median imagery, f2 median. So it will differentiate my snow with the other part. Okay. And I have given a visualization parameter of cyan. Like in cyan color, I want to visualize the snow. So I have given in a dictionary format palette equal to cyan, palette colon cyan. And the name is sentinel snow cover. Okay, any doubt? Anyone? Do you have any doubt up to this part?
Sir, one thing is there, if these are images of different time periods, for example, 5 days, 5 days, 5 days. But the thing is, these pictures are merging, how we
Mhm.
can say that this is the average snow cover? Because it will represent the average snow pixels which are available in the all the pictures.
Yes, you are right.
So how?
Actually, uh, uh, for that, if you are taking multiple date imagery, then it becomes difficult because some part snow will be less. In some
Yes,
days,
sir.
snow will be less, and some days snow will be more. And
More.
when you will take the median, the value will obviously, when you will take the mean, the value will change. So that's why now it is recommended, like for every image that you know has generated, every single image which gets generated, you need to estimate the snow area separately.
Okay.
This median will simply mean or median will simply remove that one. Like it will simply calculate the mean of that image, which might not be correct.
Yes, sir.
So,
Yes, sir.
so it is better practice that you apply a function, and every calculation should be done on every single image. Like greater
Okay, sir.
estimating histogram also should be done for each image, so that every value should have its own histogram and its own क्या कहते हैं, its own threshold value.
So, sir, you are
And
saying if there are 4 images of a month, we have to
हाँ,
calculate the snow cover, then we can say what is the mean snow cover of for this month or for this season.
yes. So for the 4 images, you have to calculate separately.
Okay, sir.
That
Okay, sir. Thank you,
that
sir.
that will give you the best value. If
Okay,
you
sir.
will
Okay, sir.
if you will take the mean initially only, then it will not give you the best value.
Okay, sir.
Okay. So threshold part someone has requested to repeat. So I am giving from the standard value, as we assume ki zero point 0.4 value differentiate or estimates the snow cover. So I have given value of 0.4, and this differentiates the NDSI. From the NDSI, this greater than 0.4 gives me the value of snow. But this may not be correct and it varies with the images. For that, we need to calculate the histogram, which I have already written a code here. Variable histogram. Achha. I've already written a code here. What this code does, it generates a histogram. And from here, we need to get at with which value. See, it's a bi-modal histogram because one peak is appearing here at the right part and one peak is in the left part. And we need to check where the value is minimum. And it is almost here around 4, 4.5, 4.5 के आसपास, 0.4 to 0.5, the value is minimum. So we are able to say कि okay, our threshold is around 0.4 or around 0.45. But this value will change if you will change the region or if you will change the area. Sometimes this value also change. Like if I will take it towards Ladakh area, you will see the value will be reduced, a bit reduced. Now the threshold will come around 0.25, 0.27. So that 0.4 value is better suitable for Uttarakhand, Himachal, where there are greeneries and land. But in case of Ladakh area, we have seen that the value is a bit lesser, toward 0.24, 0.25, 0.26. So that thing needs to be estimated. That threshold needs to be estimated from the histogram. That is the best practice. Otherwise, you can assume 0.4, that is fine, but that will not work for every case. You need to check through the histogram. Okay. Now the next part comes ki suppose we have now we have estimated the snow area, we have estimated the snow cover. Now we want the area of the snow. Like here, I've shifted my threshold area. I shifted my area to Leh, so currently this is my So now next part comes ki how to estimate the area, which the code which I have already shared. So what this code does, it takes the snow cover variable and it multiplies with the image pixel area. So my image pixel area is 100 because it is sentinel pixels. So it will auto this ee.image.pixel area will automatically calculate the area of each pixel, which needs to be multiplied with the snow cover so that the total area of snow cover is calculated. Like this will calculate the area for each pixel, and this reduce region. This reduce region is a reducer which will add all the value of each pixel area. Like inside this snow cover, my snow cover is only this cyan part. For that cyan part, all the pixel area is calculated, and using this dot reduce region, we have used the reducer sum. So what this will do, this will calculate, this will add all the areas, all the pixels which are present in this cyan color, and it will try to add. This reduce region takes reducer as an input, geometry, scale, coordinate reference system, transform, best effort, maximum pixel, and tile fill. A lot of variable it takes, but most of them are optional. The important ones I have already mentioned, like we need to provide which reducer you want to take. So we want to take the reducer by the name sum. The geometry is my ROI. Like for my area of interest, I want to calculate. I have taken scale as 20 because you will check the sphere band. The scale of sphere band is 20 meters. That's why I have taken the scale as 20. And maximum pixel I have explained yesterday also, like if I want to increase if my area is bigger and I want to increase the computation capacity of Earth Engine, I can take up to 1E30. Now, since this snow area, this snow, everything is calculated on the server side, so we have to use this function ee.number in order to get that value, how much area we are getting. So we will type ee.number area dot get snow cover. We need to get from the server side. We get the area and we are converting it to our understandable form by typing e.number so that it derives from the server. And then we are dividing with the 10 to the power 6 to convert it into square kilometer. When I will run this code, it will give me the snow cover area in the value in the form of a number. Based on my threshold, everything is calculated. The histogram, the histogram is calculated using an inbuilt function UI chart.image.histogram. This is also an inbuilt function. It also asks multiple things like image, region, scale, maximum bucket, minimum bucket width, maximum raw, maximum pixel. But most of them are optional. Better just only the important things are give the image name, like for what image you want to calculate the histogram. Region you need to mention for what region, and this scale I have taken as 100 because at 20 scale it was saying ki it was giving some error ki there are a lot of pixels. So I have increased the scale so that pixel count is reduced. My area will be only changed slightly, so there is not much effect. So I have taken scale as 100. And this set option is generally used for the visualization of this chart. Okay, so this is just for the visualization of the chart, like NDSI histogram, this title name, this pixel counts, left side and bottom side. For the proper visualization of chart, these things are given: title, horizontal axis, vertical axis. So through this function, you can calculate the histogram, and through this area function, you can estimate the area. And the last part is the export image part that you all are aware. Yesterday we have exported them. You can export the Sentinel to snow cover. Okay, that part is same as yesterday one. Now I will take up some question, like there was some question. Okay. threshold part I have repeated. From where we can check the NDSI histogram part. This part, this line number, this line number 40 to 50 is generally used to estimate the histogram. Could this code line also modified to apply to calculate the area of other covers, wetland, vegetation? Yes, you can modify. You need to just know, like you want to modify NDSI with NDVI and then apply a threshold for a vegetation which are for forested area, like you apply threshold of 0.7 and it will give you the value of vegetation which are forested, and then you use the same method. You just give the threshold of 0.7 and then it will calculate the area of vegetation also. So that can be modified for the vegetation cover also. For wetland also, instead of NDSI, you can give 5 minutes. You can give NDWI and then that can be used to estimate the water area. If we want to calculate the snow cover area for each picture, we would need to use the dot map function to get a time series. Yes. You need to write all these functions which I have written separately in a single function. You can create a single function in which you mention all those steps and you just pass us this sentinel-2 imagery to that entire function, so that it will map and it will estimate the histogram and it will give you the area for each image. Then can we export the pixel data as CSV? Pixel data you means pixel count or pixel data as CSV. Generally, since we are generating the images, so it is mainly exported in the form of a image, in the form of an image. So it is better to export in the form of an image that later you can change that image to CSV. How we can get the monthly data? Like if you want the monthly sum, then what I told you have to take the sum from each image. Like you create a common function, combined function, and take the image for calculate the snow cover area for each image, and then add all the area for every date. Then only you will get the total snow cover for each month. For the histogram, if you will see, whenever any chart is generated, at the rightmost corner, there is an up box. You can simply download this histogram as CSV. You can simply download this histogram as CSV and it will have that value, all the band value, and you can generate the histogram in your Excel also. That same histogram is generated here also. So that every chart which is generated in Earth Engine will be associated with this CSV file. So you can directly download that CSV. It will have the pixel value. It has the pixel value of NDSI. And this snow cover area is estimated at 606, which is the value. Actually, we are running short of time. I will share this working code again, so that you may try. You just change your for your assignment. What you can do, you just change for your shapefile. You try to upload your own shapefile and try to estimate the area. And you can share your code through email or through in the WhatsApp group. You can share your code. You have estimated this much area. Work for your area of interest. Then it will be. Question kya tha? We are taking 20 because SWIR band is having a resolution of 20. That's why we have taken 20. You can even resample to 10 also. But actual value of SWIR will be in 20 meters. Yes, for MODIS also we can use the same method. Same method will be used for MODIS, but instead of taking MODIS collection already has that NDSI. If you search for MODIS NDSI, it is already there. So there is no need to calculate the NDSI, we already have the snow cover data from MODIS. We have to just provide the threshold there. Threshold, it is in percentage 0 to 100. So you provide threshold as 20, 30, depending on the histogram. And then your area of snow cover area will come. I will share you one more code, which is the combined code for MODIS, Landsat and Sentinel. That will be helpful for you. Yeah, this. Okay. In this code, I have taken all MODIS also, Landsat also, and Sentinel also. Okay, you can check this code by your own. I will share in the group, WhatsApp group, as well as I will share in the chat box. This code works for both MODIS, Sentinel, as well as Landsat. MODIS, Sentinel, and Landsat. You can go through this code also. So friends, that was all from my side. You can keep posting your question in the chat box or group box. We will have a next session on by Dr. Riaz Ahmed sir on sir topic आपका for it is on Glacier Lake outburst threat and using remote sensing how you can map the glacier. Then we will have a session by Chand Prakash, who's a scientist be here, and he will be delivering how you can map the glacier lakes over using Google Earth Engine. So we are having our next session. So you can have a 5 minutes break. So 5 minutes break. 5 minutes break. Yeah, okay, we will have a 5 minutes break. Maximum 5 minutes break. We will start at 2:22. Okay. Every histogram has a CSV here. You can download CSV here. Whenever any chart is generated, there is an option to download CSV that you can simply click and download.
कितना आधा घंटा
हाँ
कितने
Wow. Is the screen visible?
Yes, sir. Yes, sir. It's visible.
ये
आप सर रहेंगे
हाँ, ठीक है ठीक है इसको फोटो वोटो लेते हो ऑनलाइन ये
सर आप सर ऐसे ले सकते हैं ना ले लेंगे सर
नहीं जैसे स्टूडेंट्स के साथ बताओ।
वो सर कर सकते हैं बोलिए वो किस सेशन पे स्लाइड चेंज हो रही है हाँ सोहेल एक बार प्लीज चेक
हाँ सर, हाँ सर, हो रही है। और
ठीक
आप भी अच्छे से दिख रहे हो सर।
दिख रहे हैं ना ठीक
हाँ सर, हाँ सर।
यहाँ से चलाना है
हाँ सर ये से एरो से उससे भी हो जाएगा माउस से भी हो जाएगा
ठीक है मिनट्स हो गए
फिर आप स्टार्ट करो
shall we start it
Yes, sir.
is everybody ready
Yes, sir.
okay good afternoon everybody so it is the second day of the training third day of the training and now I am assigned with the task to show you the overview of the glacier lake outburst floods. I believe many of you might be working in the glaciers and glacier lakes also. Nowadays, this glacier lake outburst flood and its hazards has emerged as a severe in the form of severe disasters. Recently, we have witnessed the Sikkim this glacial lake outburst flood and how much damage and the hazard it has brought to the infrastructure, to the downstream communities, and the many people have also lost life in this region. So glacial lake outburst flood studies nowadays are becoming very much important, keeping in view the disaster which is associated with these processes of the glaciers, or the in broad we can say the cryosphere. Now, before going to glacier lakes, we are supposed to know, and I believe that most of you might be knowing the glaciers. We know that glacier is a large accumulation of snow ice and sediment and liquid water is also there. And this large mass of ice is always in a movement down slope under the influence of gravity, as well as its weight. So the glaciers, we have a large number of glaciers in the Himalaya, and the Himalaya as a result of these glaciers, due to the presence of large glaciers, is also called as the third pole. And since we are living in the era of climate change, climate crisis, we know that the glaciers are receding. And as a result of the glacier recession, glacier loss, or the mass loss of the glaciers, we see huge deposits of the glacier sediments around the glaciers, particularly near the terminus part or the snout part of the glacier. And these glacial deposits are called as the moraines. Here you can see this is the picture where we can see a water body which has been formed due to the loss of the glacier ice there. And in addition to this water body, we can see some dirty material is there, which seems to be coming from either from the slopes or which is there left behind by something that is nothing, that is the glacier that has lost. And this debris material which is there has been actually the main culprit behind the blockade or storing the water there. You can see it. So this is the process when glaciers recede, shrank, they left behind the debris material. And due to this debris material, the water which is coming from the glaciers gets blocked and the glaciers glacial lakes get formed. And here, this is a very beautiful field photograph. You can see the glaciers there in the background, where you can see this mountain clad, white mountain clad with glaciers and snow. And in the down towards the lower upper part of this lake, you can see we have some dirty material. It is the debris covered glacier part there. And then we have this large glacial lake, and on the sides, peripheral parts and the frontal parts towards the photo itself, you can see large material, debris material is there, and you can perceive that some material, ice material is also there behind this or underneath this debris material there. And this is the field photograph of the glacial lake. Now, I have already discussed about the process of how these glacial lakes are formed. So simply glaciers are there. When the glaciers shrink, when the glaciers lose mass, vertical thinning as well as the backwards recession takes place. Due to this, the debris material which is on the top of on the surface of the glacier or within the body of the glacier itself gets deposited, and the meltwater which is coming from the glacier gets blocked there behind this moraine material, and finally this results in the formation of the lake. And since there is this glacier recession is continuously going on in response to the global climate change or the warming temperature, so this glacier lake also expands in size after getting formation with time. Now, one thing I would like to bring to your notice is that before carrying out the glacial lake studies and glacial lake outburst flood studies, we are supposed to know very keenly and very vaguely the glacial lake classification. Here you see, this is the system of classification where you can see we have many classes of the glacial lakes. Then we have many subclasses also, and the description and the features or the characteristics of each glacial lake are also shown here. You can see we have glacial erosion lakes, then moraine dammed glacial lakes, ice blocked lakes, supraglacial, subglacial, and other types of the glacial lakes there. And you can also see in the description many processes are there which are responsible for the formation of these glacial lakes, and many features are also associated with each of these glacial lakes. So after knowing this, yes, this is a glacial lake, we are supposed to conduct studies, detailed studies to understand what are the different types of the glacial lakes. And this is very essential step, because once you know that this is this type of glacial lake, you can understand its mechanism, you can understand the process of its formation and how it could be disastrous. That thing you will then very easily you can understand that. Now you see these are the satellite photographs, satellite images showing the different types of the glacial lakes. Easily you can see in the first photograph there is a cirque type of glacial lake. Then we have some moraine dammed glacial lakes there. Then we have end moraine dammed glacial lakes also there. You can see many these pictures are there showing the end moraine dammed glacial lakes. Then we have supraglacial lakes also, lateral moraine dammed glacial lakes also. Some supraglacial lakes are also. Now, from these satellite images, you can easily visualize and perceive that how these glacial lakes are actually different on ground and how they look like after analyzing the satellite images. So classification of the glacial lakes is one of the important steps while studying the glacial lakes. Now this is another map showing you the glacial lake types and the classes. This is from one of our studies. Here, this is published long back in 2000, I think 2016 or 17. And the classification of the glacial lakes, which we have tried in this catchment, it is a Baspa catchment located in Satluj River Basin. You can see we have classified many glacial lakes as supraglacial lakes, then proglacial lakes, periglacial lakes, glacier fed lakes, and non-glacier fed lakes. So you can see the Google Earth images also there, how these glacial lakes look like on the satellite images, and what will be the condition in the ground. That thing we are supposed to understand in the field, and for that purpose you are supposed to go to the field and conduct the field studies. Now, this is the glaciers, glacier lakes, and types of glacial lakes. Now comes the concept of glacier lake outburst flood. So before going to moving forward, I would like a response from you people. What is the glacier lake outburst flood? Anybody can just give the definition, so that I could understand that you are not sleeping. Is there anybody? I think everybody is sleeping.
No, no, sir, no, sir. We are here.
What is glacier lake outburst flood?
Sir, it is the sudden release of water of a glacial lake due to numerous reasons. It could be dam failure, overtopping, or anything else, sir.
Okay, thank you very much. So glacier lake outburst flood is nothing. It is actually the flood which is caused due to the sudden release of the huge amount of water which is actually stored behind the moraine dam, and there may be many factors that are responsible for causing the breaching or bursting of the moraine dam, or what type of dam is there, and then releasing this huge amount of water. Then when this huge amount of water comes, flows downstream is very rapidly and with high speed, with huge mixture of debris, snow, ice. So it results in a type of flash flood, and that causes a huge damage. That is how this glacial lake outburst flood is defined. Now another thing is there, that is, this is GLAF. Another thing is LLAF. This is a landslide lake outburst flood. Here the process is one typical difference is that in case of glacial lake outburst flood, we have the damming material, that is a glacier borne material, that is moraines, that is the material that comes from the deposition from the glaciers. Now, if sometimes some landslide happens and dams the water, for example, the stream or the glacial stream which is there, it also results in the formation of lake, and that type of lake is called this landslide type of lake. And if outbursting happens in that case, that will be called as landslide lake outburst flood. Now, if you see here, you can see how after breaching of the moraine dam, how the lakes are become empty and release huge water and become empty. And what is the scenario here? You can see this is the field photograph. You can see how it looks like after getting outburst flood. Now, there are many factors that actually contribute to the glacial lake outburst flood. And these factors, you can see we have many types of factors, like we have a large lake volume, narrow and high moraine dam, stagnant ice within the dam, and limited freeboard between the lake level and the crest of the moraine dam. In addition to this, we have another important factors that lead to the glacial lake outburst floods include the calming type of glaciers, hanging glaciers. Recently, there has been a collapse of the hanging glacier, and that has caused a huge damage to the village as a result of that flash, that debris slide and this landslide recently. Can anybody tell where it had happened? Just few days back.
It's British Glacier in Switzerland.
Okay, now you just you see that the hanging glacier or glacier collapse caused large landslide there and engulfed the whole village. Now you try to perceive if there is a glacial lake also in that. If this process happens and if there is also a large glacial lake, what could be the condition? What could be the damage? How much what could be the nature of the damage? You can perceive from that this process that hazard also. So there are many factors like calming glaciers, hanging glaciers, rock falls, settlement, piping. Many factors are there which lead to the glacial lake outburst floods. Now, this is the picture you can see easily here. What are the key processes that lead to glacial lake outburst floods? You see extreme snowfall or the rainfall or the cloudburst process. And if we have glacier, that's the ice calming activities happening there. If some ice avalanche or rock avalanche or sediment avalanche type of process happens, that can also lead to glacial lake outburst flood. Landsliding, this is one of the frequent processes happening throughout the Himalaya that can also lead to the glacial lake outburst floods. In addition to this, if we have ice dam lakes that are much more vulnerable to this glacial lake outburst floods, earthquakes inherently are very much responsible for the glacial lake outburst floods, but there is not any report so far that the glacial lake outburst has been caused due to the process of the earthquake. And after this water gets released, you see the first and most important impact will be on the downstream community. And it may be that there are some communities, there are some villages, there is some roads, some other infrastructure, hydropower projects are there. And sometimes people also lost their lives if they come under the influence of this glacial lake outburst flood. Now you can see one of the schematic example of how this ice calving activity can also lead to the glacial lake outburst flood. You can see here, if some ice calving activity is happening on the glacial front, it can, if it falls into the glacial lake, it can lead to formation of some jet waves, and that waves can overtop the moraine dam, which is inherently unstable because it is composed of unconsolidated material, and that material can easily get eroded away, and it can lead to the release of this huge amount of water that is stored behind this moraine dam lake. So it is one of the processes that can lead to the glacial lake outburst floods. Now here you can see this is again showing the processes or the mechanism of the glacial lake outburst floods. And here we see we have three types of these dams. One is glacier ice dam, moraine dam, then ice core moraine dam. And you can see how there are different processes, what different types of processes are there, which can play their part to cause the this glacial lake outburst flood. Now, looking at this image, you can easily see what are the impacts. And we know that we have been witnessing from last few years, and recently in 2023, we have witnessed this process in South Lonak Lake in Sikkim. So nothing to discuss about this. We know that once this glacial lake outburst flood happens, it causes damage to many things, many components of the surface of the earth. You can see here, we have this agricultural field, forests are there, settlement is there, some infrastructure, hydropower projects are there, which are easily that can be attacked by this glacial lake outburst flood. Now, looking at the Himalaya, we have a real threat and increasing threat from the glacial lake outburst floods in the Himalayan region. Because you see, in this Himalayan region, we have been witnessing that glacial lakes are there, glacial lakes, new glacial lakes are coming into play, and the existing glacial lakes are increasing in the size. When the glacial lakes are increasing in the size, means the volume of the water in these glacial lakes is increasing. And we know that in the Himalayan region, which is very seismically very active, tectonically very active, and very prone to landslide activities, this region is highly vulnerable to glacial lake outburst floods. So everything is in positive contribution. You see, we have landslides there. It is seismically very active. Cloud bursting and rainfall events are happening there, and large number of glacial lakes are there. So all these things, when we integrate, we find that Himalayan region is most vulnerable to the glacial lake outburst floods, and it is a real threat we have been witnessing in this region. Now you see, these are some studies which show how these glacial lakes are expanding very rapidly. Now my slides are moving.
Yeah, yes, sir,
Please.
they are moving.
Somebody has problem. I think it is a problem with him there itself. Please try to reconnect. Your problem will be solved. So you see, these are examples from the Himalayan region. You see how these glacial lakes over a period of 30 to 40 years have been expanding very rapidly and very fast. You see there, you can see how the glacier recession has been taking place, and consequently you can see how these glacial lakes have been expanding in this region. These are examples from the Ladakh Himalaya, one of the studies which I have carried myself, and another from some other body. So you can see it here. Now here you can see the glacial lake outburst flood distribution. You see, in the northwestern Himalaya, we have a large glacial lake outburst flood events which have been mapped there. And if you look at this map, you will see throughout the Himalaya, we have glacial lake outburst flood events all over in the Himalaya. Means the people living in this Himalayan region are vulnerable to the impacts of the glacial lake outburst floods. They are not free. They are not at the escape of any glacial lake outburst flood. The threat of glacial lake outburst flood is there, and it is very clearly evident in this photograph. Now, coming to this was the overview, just overview of the glacial lakes. What are the threats? How glacial lakes are formed? What are the different types of the glacial lakes? I hope you could have understand during this brief this overview of this glacial lakes. Now, coming to the modeling, how we could study these glacial lakes. There are many steps that are involved for studying these glacial lakes and for studying and understanding the glacial lake outburst floods. And the first one is to map the glacial lakes. Now, first one is the mapping of the glacial lakes, and for this purpose you can use satellite and remote sensing data. As you have been studying this Google Earth engine from last 2 days, Google Earth engine is one of the best techniques and easily accessible fast processing technique where you can map the glacier lakes very fast at the cost of minimum time. So in the next lecture, you will be shown how glacial lakes can be mapped using Google Earth engine technique. But satellite data, you can also use that. You can use different types of satellite data, and you can use artificial intelligence, machine learning techniques for the map. And this is the first step, mapping glacial lakes. Now, another thing is classification of the glacial lakes. That is also very important, as I have already discussed many types of the glacial lakes in the previous slides. So these are the steps. Many workers have developed their techniques, have used their data of own interest depending on the resolution, availability, accessibility, everything. So many steps are involved here. You can see this is workflow of the methodology which can be applied to the different satellite data for mapping of the glacial lakes. And this is not standard technique. You can use whatever technique you can apply, fits best to you, suits best to you. And finally, the final purpose is that we should have a glacial lake inventory, and glacial lake inventory should be classified later into different types of glacial lakes. Now, different automatic techniques you can also use here, using different thresholds, using different indices for the processing of the satellite data, so that glacial lakes can be very rapidly mapped. Then these automatic processes also need some post-processing validation or correction to be applied, so that the final glacial lake, this lake inventory becomes very suitable and authentic and very correct to its correctness. Now, these are the satellite images showing you the glacial lakes. You can easily see how glacial lakes look like on the satellite images. And this is after processing the data, satellite data, after generating this NDWI image, how this lake looks like, how you can extract that. And you will be learning after this lecture using this Google Earth engine, because our focus is on Google Earth engine. This is just an overview of the technique. Now, glacial lake inventory has been generated by many people, and this is the glacial lake inventory from ISRO. You can see many river basins are there, how many number of glacial lakes are there, and what is the area that are covered by these glacial lakes. One thing I would again focus on, that we are supposed to classify the glacial lakes as well, because that will give us more understanding when we come to the mitigation measures, providing some mitigation measures or controlling factors. That time the understanding of glacial lake types will be very much useful. Now, second step is to identify which lakes. After generating glacial lake inventory, second step is which lakes are very potentially dangerous, means that have the potential to cause glacial lake outburst floods. And people have used different indices, different parameters to understand that, to delineate and identify potentially dangerous glacial lakes. This is one of the examples from our work where we have used many parameters, analyzed those, and then we finally classify glacial lakes, whether the glacial lake is potentially dangerous or not. Many factors are there, you can see in the list. Now, you can also conduct this glacial Gloff susceptibility modeling. That is again the same thing, identifying potentially dangerous glacial lakes. And you can see in this workflow, many parameters have been used by these authors. This is from IIT Mumbai, this work. So you can see many parameters depending upon your accessibility, depending upon your energy. Also, you can utilize and identify the these potentially dangerous glacial lakes. Now you can see it here. You can see the factors which we have discussed again. Here you can see there are more than 10 factors which are there which make a glacial lake potentially dangerous. And this picture you can see from this paper. If you need, this paper can be shared. So you can see these are the factors which make a glacier potentially dangerous. Now you can generate then these glacier lake outburst flood susceptibility maps also, where you can show potentially very high potentially dangerous glacial lake. And then you can classify as you are doing in case of landslides. Like that, you can do that here, suggesting some lakes depending upon your data and analysis, very high these lakes, high lakes, medium lakes, and in terms of Gloff. Now, third step is how much water is stored within the glacial lakes. That is very important because the flood is actually caused by the water of the volume of the water that is there. So how much water is there within the lake? The estimation of that water is very crucial. And people have used many empirical equations that have been developed by many people throughout the world, in the Himalayan region also, and utilizing that empirical equations, people try to estimate the this water volume of the water which is in the lake. In addition to the empirical equations, we have nowadays these techniques where you can use the sonar, radar, USV, these equipments to estimate the depth of the and generate the bathymetry of the lakes and estimate the depth of the lakes. And finally, you can, out of that bathymetry, out of the depth of the lake, you can estimate the volume of the water. And this is the better technique because this is done in the field itself. It is not dependent on any empirical equation. It is just field data, you can say. Now, after understanding these things, another thing is to identify the Gloff triggers. As we have seen, there are many triggers. For example, there could be landslide, there could be cloudburst, heavy rainfall event, there could be ice calming activity. Many factors are there. Even there could be earthquake, seismic activity like that can cause the glacial lake outburst flood. That's a trigger. So for that purpose, you can also take up the study and use many softwares, like we have RAMS model, we have basement model. These models you can implement to understand these triggering factors of the Gloffs. Now you see here you can see the trigger. This is the South Lonak Lake, which has recently outbursted. You see landslide on that right, this left corner, you can see landslide was actually the trigger that caused this glacial lake outburst flood. So you can utilize even SAR data to see the movement of the surrounding slopes to identify the trigger which may strike the lake and cause the glacial lake outburst flood. It is the same. You can see there difference where the landslide has occurred in the this morphology of this lake. Now, another important thing is that dam breach. That is very important. That is how this moraine dam is there, how it can breach. Breach means break, or how the spillway is created within that dam break. So for this purpose, many equations are also there which are utilized to understand this moraine dam breaching. So you can see these. Another thing is flood wave movement. So simulation of this flood wave movement, and again there are models, there are equations that are being used to understand this flood behavior. These are some equations. We are not supposed to go into the equations. I am just showing. So these are the breach parameters. You can see many equations are there. So you can utilize, depending upon your utility or the stability of the data, you can generate these breach parameters. Yes, finally, the Gloff modeling is done, and these all parameters are then given input into the model, and model runs, gives us the flood maps. After that, we generate these hydrographs also, and depending upon that, we can further analyze data to see the potential of the lake and how much hazard it can cause. That is a later process after doing the modeling. Now, you see, this is the damage. This is the energy of this glacial lake outburst flood. You see huge boulders, huge sediments are there, huge, you can see dumping of the material is there, which is being done by this glacial lake outburst flood. This is the energy, this is the damage which is associated with these processes. You can see it here, the damage. These are some field photographs from South Lonak Lake, Sikkim. You can see how much damage it has the potential to cause the damage. Now, these are the hydrographs. You can see this is the flood hydrograph of the glacial lake outburst flood. And this is generated after applying some modeling. For example, we are doing it with Mike 11 or HECRAS model. So this is the flood hydrograph of the GWR. Now, again, this is showing the existing dams, means hydropower project dams. You see how it has damaged it. Now, you can also generate the flood maps. For that purpose, you can do the flood hazard and inundation mapping to see the flood damage and the extent of the floods. And for this purpose, you can also conduct this modeling, and under different scenarios, depending upon the discharge amount of the discharge which will be coming out of the glacial lake, and you can generate these inundation maps to understand whether our area or any infrastructure which is there is coming under some flood, under some certain given these scenarios. Given scenarios, you can delineate that process also. Now, finally, there is the mitigation. After learning about this glacial lake outburst floods, how it can be understood and modeled. Now, the final output is that we have to provide the mitigation measures so that we could prevent the community, the infrastructure from the damage which can be done due to this glacial lake outburst flood modeling. That is the mitigation part, how we could escape or we could preserve from these damages. So you can see there are many people, many mitigation measures have been suggested. You can see we have short-term actions, long-term actions that are supposed to be taken for the mitigation measures. And here you can see lowering of the water level in the lakes is one of the techniques, artificial drainage of the lake, providing reinforcement, enhancement of the river cross sections and protection from the erosion. Many processes are there that are involved for the mitigation measure. Now you see here, these are some examples how this draining, artificial draining, lake draining is done so that the water can be reduced. Actually, the volume of the water which is within the lake is dangerous. So if we could release this water very safely under controlled conditions, we could reduce the impact or the risk which is coming out. So this is how mitigation measure can be done. So sometimes we can also regulate the land use, land cover, where we are supposed to not do our construction in the areas where flood, this vulnerability of flood, coming of the flood is certain. So for that purpose, we can use this land use regulation so that we could prevent from the glacial lake outburst floods. Now you can see this is again land use regulation. Now you can see sometimes we are supposed to strengthen our infrastructure which is there, and there are chances of coming under the influence or the impact of the glacial lake outburst floods. Means we have not to compromise with the quality of the construction. We are supposed to make construction as strong as possible. Last one is the developing early warning system. Early warning system is one of the most important requirement so that we could mitigate from the emerging threats of the glacial lake outburst floods. And for this purpose, we are supposed to take into account many things, like we have to take into account the climate, prevailing climatic conditions. We have to monitor the water level fluctuations of the lake in the field itself. Means we have to develop the infrastructure around the lakes itself. We can utilize the satellite or this remote sensing data here very successfully. And many things are involved in developing this early warning system. And if this is developed, this is the most viable way to prevent from the emerging effects of the glacial lake outburst floods. So this is again, and so I will show you some studies which we have conducted. Actually, I was given half an hour. I think I have completed within the time, but I will just throw these some slides which we have conducted our studies. You can see these are the two lakes in the Zanaskar Himalaya, which we have studied long back in 2015 or 16. So you can see how the lakes have been expanding, and we have studied these lakes. You can see the routing of the flood through streams there, shown by that purple color and a river profile. So we have done this glacial lake outburst flood studies there, and these are the analysis where we have tried to analyze the trigger that could act upon these glacial lakes to cause the glacial lake outburst floods. You can see we have shown though they are the zones where the probability of rockfall sliding is there, and there is some ice calving activity also there. So these are the parameters which were developed and then given input into the model to develop the flood hydrographs. And these are the routes, flood routes you can see where through we have developed these river cross sections and finally come up with this river discharge through modeling. Mike 11 was used for this purpose. And these are the flood hydrographs of these glacial lakes. And this is another study in Gangabal Lake in Kashmir, Himalaya. You can see this is the lake, this is the Jhelum Basin. We have utilized, this is one of our students, he has done the study and how the data he has used. And this is the overall methodology adopted during the study. These are some river cross-section profiles you can see. And this is how the sources of mass movement triggering factors are identified. These are showing the areas of the mass movement. And these are the flood hydrographs which are generated for this lake outburst flood. And at different locations, we have tried to generate these flood hydrographs to see the impact at different locations. Because when the flood comes from the lake, in downstream areas, the influence or the extension of the flood becomes less, it gets reduced and finally diluted. So at different locations, we have tried to see the impact. And these are the flood hydrographs you can see. This is the velocity depth of the water which is coming of this flood. Then typing over this Google Earth to see the impact on the local community or the infrastructure or the villages there. And you can see these are again the same thing. This is land use land cover, impact on the land use land cover. And these are some recent examples from the Indian Himalaya. You can see this is Kedarnath Glacial Lake outburst flood in 2013. Huge damage was caused due to this. And you can see this flood was initiated due to cloud burst, then bursting of the Moraine Dam, and whole this area was damaged. And this is Gaya Lake in Ladakh. And you can see this Gaya Lake, huge damage was caused to this Gaya Lake due to the Gaya Lake outburst flood. And with this, thank you very much. Is everybody sleeping or is there anybody there? पता नहीं चलता यहाँ पे.
Thank you,
Sir,
sir. Thank you so much.
Sir,
Amazing,
can
sir.
you do block modeling in Hack HMS?
Yes.
Can we do block modeling in Hack HMS?
Yes, we will do glove modeling, but in the next time. नहीं करते हैं या कैसे? No, it is in Hackras. We can do glove modeling in Hackras and Mike 11. Actually, Mike 11 is used for one-dimensional graph modeling, that is flood hydrograph generation, and then Hackras we can develop these velocity maps, flood inundation maps, depth maps we can generate. But if you want to learn this, the next training is coming for that. सबका I request him please
Everyone, please turn on your
this video.
Turn on your video. We will have a group photograph.
For group photograph.
PPTs will not. We will be sharing the recording now. From the recording, you will get all the information.
There is some question that from where we can get secondary data of glacier lakes. There are two things. One is data of glacier lakes, then secondary data. What is secondary data? What do you mean? What do you actually require secondary data? So glacier lake inventories have been generated by the people. Many parameters are there associated with the inventory. ICMOD, ISRO, and other organizations are there. There are many Chinese people are working, and Kashmir University people are also working on this. We people are also, we have developed a few inventories. So sometimes these inventories are put on the website and made easily accessible to everybody. You can download that data and analyze. इसमें ये ब्रेक क्यों आ रहा है?
ये वो सर बैकग्राउंड का है ना, इसलिए वो
I could see Suhail. Suhail, have you learned from this training? You were last time also in some training there.
Yes, sir. Yes, sir. Yes, sir. A lot, sir. That's why I
Okay.
am here, sir.
Very nice, very nice.
Yes, sir.
And one of my friends a few days back had informed me to join. I could not see him. Imran. Imran is there.
he is there, sir. ये तो
Imran from GSI.
साई से
I think he is sleeping. Anyway, thank you. Thank you very much. Now your next session will be on hands-on practice. That is more important than theory. The purpose of giving theory is to refresh your knowledge and give you overview of the things. Actually, why we want to study these things, because many people in this training are very new to this training. Some new freshers are there also, and we hope after attending this training, they should continue their studies in this domain, that is cryosphere and hazards. So with this, I thank you and wish you all the best for the next session.
Thank you, sir. Thank you
Thank
for
you,
your
sir.
informative session. Next, we are having Chand Prakash here. So he will be giving you hands-on glacier lake mapping. He has shared a code in the group, and he will be sharing in the chat box also. Okay. So
Okay.
good evening. I will give you access to it.
Hello. Good evening to all.
Good evening, sir.
Am I audible?
Yes, sir. Yes, sir. You are.
Yes, sir. Yes, sir.
Am I audible and my screen is visible to all
Yes,
of
sir.
you?
Yes, sir.
Please respond.
Yes, sir. You are audible and you are visible also.
Okay. So, shall we start?
Yes, sir.
Please respond.
Yes, sir.
Yes, sir.
एक setting हो देख रहे हैं। उनकी आवाज वहाँ पे आएगी, ठीक है?
Okay, sir.
और तुम्हारी आवाज जा रही है, ठीक है? वीडियो ठीक है। पहले वो चलिए तो स्क्रीन लगा, तो ठीक है, ये मैं ठीक है।
Am I audible to all?
Yes, sir. You are
Yes, sir.
audible.
Yes, sir.
Yes, sir.
You are audible, sir.
But your video is very dark.
Screen, no?
हाँ, screen।
Okay. Okay, my screen is also visible to all.
Yes, sir.
See, in the last 2 days, we have gone through the different sessions related to the Google Earth Engine, in which you have all got the idea about. Dr. Sachidan Singh sir has informed about, just given the very informative lecture about the platform of Google Earth Engine, about the where the assets are available, where the console, where is the main window in which we have to just write the JavaScript, and where we can see the results. I hope you all have got the idea about these things, and you all have aware about the Google Earth Engine platform. Okay, and you all have gone through the how can we write the code in Google Earth Engine, and in which how to write variables, how to define dictionary, how to define list, how to define functions, how to write these things. So you all have got idea about the things, right? Means you all are now in a little bit comfortable zone with the Google Earth Engine. Okay, everyone.
Yes, sir. Yes, sir.
Okay. Now, in the previous lecture, you have all you got the idea about what is GLOF, what is GLOF modeling, what is GLOF mapping, GLOF glacier lake mapping. So in these sessions, I will just demonstrate you how we can how we can just map a lake. Okay, a glacier lake. Okay. And can you please, before starting this, I have shared the code in the WhatsApp and also in the chat here. So I want to just make this session for interactive. So can you please just say what is glacier lake and why it is important to map the glacier lakes? Anyone, please?
Sir, for mitigation strategies.
Sorry.
For mitigation strategies.
Yes. Fine.
Lake that is formed due to retreat of the glacier.
Yes, that is glacier lake. Okay, fine.
So the basic thing is that we have to monitor the lake, because if it's glacier lake, it's a hazard
Yes.
somehow. So for
Okay.
monitoring, we have to map it.
Yes. So,
Yes, sir.
and it is true that the glacier, for monitoring the glacier, because to just solve the disastrous issues that happens due to glacier lake outburst flood, and we also know that the glacier lakes are located in the very remote areas. Okay, in very remote areas in the higher altitudes. So we cannot just go and map the glaciers very frequently because it's very difficult to do this. Okay, so in the era of we are living in the era of remote sensing. Okay, so we can map these glacier lakes by using the remote sensing. By using the remote sensing images. So you all have got the idea about the Landsat image in the previous session, in which the Sentinel image in which you have got the idea how to just calculate the NDSI and snow cover, how to generate a snow cover map by a Sentinel images. Okay. So similarly, there are so many images like Landsat image, Sentinel 1, Sentinel 2. There are various series of Landsat images. So I hope you all have idea about what is Landsat image, what is Sentinel image. Okay. So in this session, we will map a glacier lake using the Landsat image. Okay. And in the previous session, you have calculated, you have estimated the NDSI, normalized difference snow index. And now, can anyone tell please how can we map the lake? Okay, or we can or just tell me how can we map any water body, or how can we map simply the water on the earth? Just left lake, any lake and any water body areas. Okay, I am getting the answer. NDWI. Fine.
NDWI index. Yes.
Fine. Good. So NDWI is no, not NDVI. Yes, you can use NDVI also. You can use NDVI also, but the most correct, the most effective index is NDWI. Okay, non-wise difference water index. Fine. So I have shared the code in the chat box and in WhatsApp also. Please open this code in your computer screens first. Just open the code. You will know. So first of all, open this code in your computer screen and let me know, is there any difficulty in doing this? The same thing should come in your window.
So computed object error is shown.
Just refresh your page.
Refresh your page.
Okay.
So I have shared the code here. I'm also opening from this window. Okay, everyone is able to just open this code.
Yes, sir.
Say yes. Anyone have any problem?
No, sir.
These similar windows should be open in your systems. That is open that is already open on my screen. Okay. See, in this till now, when you open the code, you are not able to just save the code. So you have got the idea how to save this code yesterday. Just click anywhere and place a space. Okay. So you can save the code, but you need not to. If you want to save this code in your in the script in your Earth Engine account, you can save. But just you can save after a bit. Just first of all, just look what is happening in this code. Okay, I will explain each part of the code one by one. Then I will finally run this code. Then you have to run this code on your systems. At first, you will run with the same save file that I have given in with this code, and then you can run this same code on your area. Okay, on your save file. Fine. So I am explaining the first part. The first part, that is input parameter. You can see here input parameters. Fine. See here, what is this? First is variable. There is a variable that is lake boundary. Okay, I have just written a lake boundary in which I have given the AOI. What is the AOI? Here we can see I have already imported the AOI. Okay, you got the idea yesterday how to import the save file as an asset in Google Earth Engine, right?
Yes, sir.
Right. You can see here in my assets there is already what is the name of the save file? That is South Lenong Lake. I'm just doing the analysis for the South Lenong Lake. You must have all of you aware about the South Lenong Lake in Sikkim. Okay. So you can see here I have already exported as an asset in my Earth Engine account in an Earth Engine project as an asset in repository, that is South Lenong Lake. Here you can see it has been imported here as a save file. Then I have imported here and just give the name of the variable at AOI. Okay. Fine till here.
Yes, sir.
You all have got now you all can just import save file as an asset in Earth Engine.
Yes, sir.
Can you all export?
Sir, shape file of lake.
Yes, save file of lake or save file. I am not talking about lake only. Means you want to, if the save file in which you want to work upon, this I want to know that you are able to import the save file in the Earth Engine account as an asset. Means I want to know that all of you got the method how to export the save file in the Earth Engine account.
Yes, sir.
Yes, sir. Yes, sir. That
Yes,
was
yesterday you got the session,
that was yesterday
on
taught.
this.
Yes, sir. Yes, sir.
Okay. So
Yes, sir.
first one the clear. I have just created a variable that is lake boundary in which what is this AOI? AOI means kya? Lake, the area of the lake boundary of the boundary of the lake. Okay.
Okay, sir.
And the other one is a variable start date and the variable end date, in which I have mentioned you can see clearly there is a date that is 1/1/2000 and till 1/1/2025. Okay, means the analysis will be carried out from 2000 to 25, therefore 25 years. Okay, this is the start date and end date. Fine, till here.
Yes, sir.
Okay.
Yes.
That is the second one is masking function. In the previous session, you all you have gone through the details how to mask anything. Okay. So here, first of all, before doing the NDW analysis for NDW analysis from a Landsat image, we have to just mask the cloud from there, from the image. Okay. So there is a function that is mask Landsat clouds. Here, what is this QA pixel? QA pixel is a band in the Landsat image. Okay, I will show you what is this QA pixel and how we can just process how we can just mask the clouds from there. And where there is a variable QA that stores what? QA pixel. Okay, the QA pixel band of the Landsat 7 on the Landsat image, and there is a variable that is cloud. Okay, what is the variable cloud doing? Actually, it is masking the cloud. That is a bitwise operation is carrying on here. In the QA pixel, there are different types of band, which is shown by different bitwise numbers. Okay, so we have just we have written here a function to just by using the bitwise operation to do the bitwise operation in the QA pixel, and so that we can mask the clouds. Okay, from the Landsat image. Fine. Fine till here. Okay. So I'm moving forward. Here the NDWI function. NDWI actually here I'm not written. We can write here. NDWI can be calculated as green minus NIR. Okay. By green plus NIR. Okay, this is just simply the normalized difference method of to calculate the NDWI. So to just calculate NDWI, I have created a function that is compute NDWI. Fine. So and there is a variable that is NDWI. I have written a variable NDWI in which normalized difference has been calculated using the band 2 and band 4. So why I have taken only band 2 and band 4 here? I have written here, that's why. That is green minus NIR by green plus NIR. Okay. So the Landsat image are different types of band. Okay. Each image are different types of band. I can show you. I will show you there. So band 2 is representing here green band, and band 4 is representing here NIR band of the Landsat image. Okay. That's why we have taken band 2 and band 4 and just taken the normalized difference to get the NDWI. Okay. And the other one is I have written something system time start. It just do one thing that it will just process everything from the starting date. Okay, that you have given here. Okay, here. Fine. Then in the next line, I have just loaded the Landsat 7 image. Okay. The Landsat has different types of series, like Landsat from Landsat 5, 6, 7, 8, 9. You can import here different series of Landsat images according to the time period for which you want to just study the lake or the any area. Okay, I have taken Landsat 7 image here because I am doing the analysis from 2000 till 2025. And Landsat 7 image comes in 1999. Okay, that's why I have taken 2000. Okay, so if I will take here Landsat 8, it will not work. Why it will not work? Because Landsat 8 came in 2013. Understand? Why I have taken Landsat 7 here? Fine. So here, first of all, I want to show you this Landsat 7 image. Just copy this Landsat and just paste here. You will get the details of the image, complete details of the image. There's a description, how a collection is, how you can call this image in your Earth Engine script. Here it is already written. Okay, it is image collection. Landsat 7 is the image collection. You have all got this idea about these things, what is image collection and all in the last 2 days sessions. Okay, so this is the image collection of Landsat 7. So this is the description about the image. This is the most important thing is about to know is that bands available in this image. Okay, these bands are different in different images. Okay, so you have to very wisely select the band names during the coding, otherwise error will come. Okay, so there is bands. There you can see here SR underscore B1, SR underscore B2. Here I told you na that is band 2 is green band. Here you can see green. See, and band 4 is near infrared. See, NIR. Okay, that's why I've taken band 2 and band 4. Fine. In NWI. Okay. All of you fine till here?
Yes, sir. Yes, sir.
See, similarly, you can see there. Similarly, you can see. I told you, there is QA pixel band. Okay, that is used QA pixel bit mask. I told you, QA pixel band, and there is beat-wise numbers as given for each of the types of classes in the QA pixel. See, okay. So to just remove the cloud, you can just you can here see that the bit 3. So I have done the operation using beat-wise bit numbers of the QA pixel. Okay. So these are the different types of band of the Landsat 7. You can see here, and there are so many things, are image properties, terms of use and all. You can get all the idea about this image of any image here by just typing here the image. Okay. So Landsat 7, I have just defined a variable Landsat 7. Okay. What is this? There is an image collection Landsat 7. Okay. Landsat, the Landsat 7 variable stores the image collection of Landsat 7. Okay. Fine. This is the variable. Okay. This is the image collection. ठीक है यहाँ तक? Fine. Then
Yes, sir.
what I have done?
Yes, sir.
What I have done? अब क्या करेंगे हम लोग? What I have done this? अब I have just apply a filter. There is a Landsat image of all over the world, but I don't want to work on the whole world. Na? I just want to work on our area. Okay, our area of interest. And what is this? Our area of interest is lake boundary. Okay. So I have apply a filter bounds lake boundary. It will just do the analysis within the lake boundary. Okay, that I have uploaded here. This is lake boundary. Okay, this is the variable lake boundary. And what is this? Our area of interest. Okay. Any problem till now?
No,
Fine.
sir.
Okay. Then I have applied again next filter, that is filter date, a start date and end date. I don't want to study the complete date of the Landsat 7 images. I want to study our study period in which I want to study actually. So a start date and end date, that I have defined already here in the start date and end date variable. Okay. Fine. Then I have just apply again a filter, that is cloud cover. The cloud cover is of 40%. You can increase or decrease this according to your bill. I have applied here 40% for the sake of study in this lake. Okay. Then variable mask, that just mask that define the cloud mask image. And then again I have selected the SRB1, SRB2, SRB3, SRB4 and SRB5 band that is already available in the with this name. And I just rename this band as B1, B2, B3 and B4. You can use same name also. You can use same name, but I have just remained for the sake of easiness that I B1, B2, B3 and B4. Okay. So this is the this stores the Landsat 8, Landsat 7 image. That is filtered out for our area, that is filtered out for our date, and that the cloud cover of 40%. And again I have renamed the band to B1 to B5. Okay. So now then the NDVI is calculated now by using the bands. Okay. You can see map.compute NDVI. Okay. This what will it do? It will use these bands and compute the NDVI, NDWI. Okay. Of that area for our area. Now, actually in lake mapping, two things will happen. First is that we just calculate the NDWI for the complete period of a study. That shows the These are actually the band correction factors. These are multiplied, that things are the band correction factors that is already given in the images. You can see here in the image. Okay. So, for mapping any lake, what I am telling that for mapping any lake, first of all, or any water body, first of all, you have to just about the presence of water in that area, and the presence of water in that area is being calculated by using NDWI. Okay, so first of all, we have calculated the NDWI for our region between 2000 to 2025. Okay, then in the lake mapping, the second step is to know about what is the areal change. What is the change in area of the lake? How can you say that the lake is vulnerable for GWR events? How can you say that this lake is disastrous? The first step is to know about just calculate the area of that lake. How the area of the lake is changing from time to time. Okay. So this area is calculated only by using the NDWI image. Okay, available in that area from the for the complete study period. Okay, then in the next step, that is area calculation. Okay, here is a variable, that is the area feature, in which yes, anyone say. I have taken the Landsat 7 image and then selected the NDWI. I have already defined the variable. Okay, variable area. I have defined an area feature now, and then taken the Landsat image. Okay, then I have taken NDWI that I have already defined. Then I have taken the mask variable that I have already taken, in which I have taken the NDWI in mask variable. I have taken NDWI greater than 0.3. Why is there? Actually, the range of NDWI lies between -1 to +1. Okay. When we will go to 1 +1, it will increase the what will you just first of all you tell the NDWI range is -1 to 1. When I will go towards 1, what will happen? Or when I will go to -1, what will happen? First of all, you please tell me. Anyone, please? Imran sir, if you are speaking something, please say. Otherwise, please mute your mic. So the range of NDWI lies between -1 to 1. Yes. No, 5. Yes, 1 means yes. Okay, fine. So when we will go towards the +1, it will show the more occurrence of water in that area. Okay. When I will go towards -1, it will just show that the less occurrence of water in that area. So for the sake of any just running the model and showing the sample code here, I have taken the 0.3. It can change according to the area. So I have just taken only 0.3 here, greater. So I have just defined a variable mask in which what I have stored the NDWI, which is greater than 0.3 in the area. Okay. Everyone, please just confirm this. All of you got this point, because this is important point before moving further. I have just created a variable mask in which I have stored NDWI greater than 0.3. I hope you all got the idea why I am taking 0.3 here. Okay. You can take 0.5, you can take 0.6. When you will go towards 1, it will just increase the occurrence of availability of occurrence of water in that area. Fine. Okay.
Yes,
Then the other is variable area, in which what I have done is that I have used masked. Masked means it has already stored the NDWI greater than 0.3, and I have just multiply each pixel area available, the pixel area to this NDWI. Okay. Fine. That's why I would create the function of mask.multiply e.image.pixel area. Fine. to just calculate the area of that pixel in which NDWI is greater than 0.3. Okay. Please listen carefully. Please see this code very carefully. You will get the idea. But it's very easy, no problem. But you have to just see this, understand this very carefully. Okay, what is happening? Fine.
Yes, sir.
Okay, so variable area is created now. Then reducer sum means actually this is a reducer. What does is it just reduce to sum of the area in that pixel. Okay, in the reducer is a function of Google Earth Engine. So that's a reducer. A lake geometry is what? Lake boundary. What geometry is what? Lake boundary that I have taken. A scale is 30 meter. Maximum pixel. You have got the idea about this thing now. One is 30 meter pixel scale yesterday. Okay, it is the maximum pixel. One is 13. What is this? Just recall.
Yes, sir. Yes, sir. Is the maximal pixel which
yes, yesterday
engine
you
can
have
process?
got these
Yes,
things.
sir.
You have got the idea of these things yesterday in the yesterday lecture, na?
Yes, sir.
Yesterday. Achha, oh, yes, today's lecture. Fine. So, okay. Then return what is this area meter square, area kilometer square. The area will be returned as area in meter square. Okay, if area kilometer square and the system timer start shows that from the time when I was given the time period. Okay. I have also written a filter here that is not null. Okay, it will just not take that area in which there is no area available. Okay, it will just remove that areas. Fine.
Sir, I have a question actually. So we are using the reducer dot add.
Okay.
But before we are using mask dot multiply.
I have written here to print a statement, but I have commented this. It is not necessary, but you can just check it. It shows what? Print number of valid images. Actually, it what shows when you will run the code, it shows that after your filtering and after your calculation of NDW and all, what is the how many numbers of valid images are coming in your area. Okay, simple area feature that I have it also simple area feature जो हमने ये यहाँ पे बनाया variable, that is variable area feature that I have stored everything. I have calculated different things like NDWI, mask area and all. It will show this and in the next part. Till now, is there any problem to anyone?
Hello, sir. Hello.
Can we also calculate the total deposited sediment?
Hello.
Yes.
Sir, could you please repeat the number lines code that is not null function?
Sorry, I'm not getting your voice, please.
Sir, could you please repeat the 52 number of rows?
52 number.
Not null function.
Oh, not null function. Okay. It is a filter only. It is a filter only that maybe in your coding, the code can take the area which have non any values. Okay. For example, you applied various threshold, various filters, but otherwise, after filtering these things, maybe after this applying filter, there will be no area available. Okay. So these things, it will remove the null areas. Okay, it will take the only valid area available according to your filter. Okay, this is the filter only for this. Fine.
Okay, sir.
Okay, Madhurima Puraga sir, by using this mask function can be also calculate the total deposit sediment area within lake or river. If yes, then what will the threshold values? Sediment. Ma'am, actually for sediment, NDWI cannot be used here. So for sediment, we can use different index. I'm unable to recall here what sediment which index is used because deposited sediment area can
index is there.
NDTI. You can just take NDTI turbidity index. NDTI. You can calculate NDTI because by using NDWI cannot just estimate deposited sedimented area in lake or river. Okay, Madhurima ma'am. And why do we use mask dot multiply but reducer dot sum?
This this mass dot multiply is generally used. Wait, my
Hello.
This mass dot multiply is generally used to calculate the area of each pixel. But we are only calculating and keeping it somewhere. But in order to get the total area of every pixel, we use that reducer as sum. So that reducer will calculate as a stats. It will work as a stats, and it will go over every image, and it will take the sum of each pixel area. Okay, so mass dot multiply is for each pixel, and the sum is for all the pixels inside that region.
Sorry, like, so why do we need to multiply to get the area? Because we are already using that inbuilt function called pixel area.
Wait. That image dot pixel area, it will take the area of that pixel. Like, means if you are using Sentinel, it will take 10 by 10. If you are using Landsat, it will take 30 by 30. And when we are multiplying it with the mask, that mask is the region which has the part of the water which is greater than 0.3. So when we are using this function, max image dot greater than 0.3, NDWI greater than 0.3, this will convert my whole image into binary 0 and 1. So one will, that line number 38, that mask is my binary image, in which greater than 0.3 will be represented by 1 and less than 0.3 will be represented by 0. So now this 1 and 0, I have a total image in which 1 and 0 are there. Now I am multiplying it with image pixel area. So that only one part gets multiplied with the pixel area, and 0, if you multiply it with pixel area, it will become 0 only. Therefore, we are multiplying mask dot image pixel area. If we don't multiply it by mask, then E pixel area will give the area of every pixel that is present inside that Landsat collection. But we want the area of only the masked part, which is greater than 0.3 NDWI. Therefore, we are multiplying it with mask. This mask is just a binary image which has the value 0 and 1.
Okay, thank you very much, sir.
And that reducer sum is adding all the area. It is adding all the area inside my ROI. My ROI is that geometry. So inside all the geometry, it is adding. So that sum is used for adding all the area.
Okay.
Sir, kindly share these codes with description. Earlier also I have requested.
Yes, we will be sharing again with the proper description of each line. We will try to
Right.
We will repeat
Okay,
that.
sir. Okay, sir.
Yes, that will be taken.
So next come is in this. Now areas is calculated, NAWI is calculated. Now I want to know that what is the maximum area? Okay, what is the maximum area? Okay, I have calculated the area, year-wise area calculated, but I want to know what is the maximum area in each year. Okay, so there is the next line. Shows this, that overall maximum area. That is I have just defined a variable maximum feature in which it will sort first. It will sort the first. It will take the area feature, the meter in the meter square, and it will just sort the areas from maximum to minimum, and then it will find that at which date the maximum area is coming. Okay. Okay, first of all, the maximum feature, the second one is maximum date. Okay, it will sort all the areas first to get the maximum area of in the year, in a particular year, and in the maximum data stores what? It just stores that the maximum area is coming on which date of which year. Okay, this is this. And then again, there is a print line, that is print maximum area in meter square, and the print maximum area year, in which year it is coming. Okay, that is the part of this written in this overall maximum area. Fine. Then is find maximum image with maximum area. Okay. In this, what I am doing is that variable maximum image. अब इसमें क्या करना है कि first of all we will just take the image of that and that date. which is giving the maximum area. So we have taken the Landsat 7, filter it for system to start from that maximum feature. अब इसमें we will get that maximum feature coming in which date. Okay, this is this maximum image. Okay, then the next one is variable maximum mask. Now it will mask from image which gives the maximum NWI. Okay, and greater than 0.3. Okay, in the lake boundary. So these are the simple things that is going on. I hope you all getting this point. Okay, fine. And the next comes map visualization. This is simple things. I have just map.center object lake boundary. Why have I written this? In the last session, you have got the idea of map.center object. Okay, so the next line is map.add layer. Add layer, I have added very maximum mask. Maximum mask shows what? Maximum NWI of particular date. And the third one is lake boundary. And the palette is blue. Maximum water extent name. Lake boundary color is red. Name is lake boundary. Okay. And you can export the maximum water extent at save file. Why I am doing this? See, I have taken just a summary. I mean, I'm telling a summary till now. First of all, I have just defined our study area, region of interest. Then I have taken the mask. I have taken Landsat 7 image. Then I have applied the cloud mask and all. Then I have calculated the NDWI using greater than 0.3, and I have applied the threshold of 0.3, and just calculated the area of each pixel using the NDWI. Then I have calculated the maximum area in which coming in which year maximum with maximum pixel with maximum NWI, and it shows actually I want to export the maximum water extent as save file. I have written here. See, okay, maximum water area and maximum water extent is calculating using the maximum NWI values, maximum areas values. Okay, so I want to know that what is the actual extent of the maximum water of that lake. So for the ASAP, it can be exported as a raster file also. It can export it as a table, various types of format file also. But for the easiness in the our research, like in our studies like law of modeling and all, we want just things in save file format. Okay, you can just analyze in as save file in the GIS software also. So I am exporting here the maximum water extent as save file. Okay, what it will export? It will export the save file, the lake bond, the save bond, the boundary, the outer boundary of the maximum water extent between 2000 to 2025. Okay, in the 25 year, it will export the boundary of the maximum water extent of that lake. It is useful, right? It is very useful. Okay, in the save file format. So how can it will help? You say, how can it will say, it will help to you in your GWR modeling or in the lake mapping or in the lake studies? How can it will help you? Why I'm exporting these things, this maximum water extent as save file? Why? Please, any one of you, please. I'll explain this. What is the necessity of exporting the maximum water extent as save file here?
To estimate the total volume which will be in that lake for that certain period of time. That's
Yes,
why
you can estimate volume part is other thing. You have now area. You can estimate the volume using the area also. So for it will give A's to you, na? Like you have now the maximum water extent of that lake between 2000 to 25. Okay, during the 25 year, what is the maximum water extent? Okay, so you can analyze these things. So this part exporting the maximum water extent. Okay, I have exported this to export table to drive. Maximum, I have taken the maximum water variable, max mask variable. Okay, so I have reduced to vector, means it just very mask max mask is what? It is a raster file. Okay, just see the difference here. Maximum mask is what? Which image? It is a raster file. I have to first just convert into vector. You all have, I hope you all have idea about the raster and vector file. Okay. So
Yes, sir.
Okay, DM, like DM, you have studied, you have gone through the sessions about the estimation of exporting DAM, just mask DAM for your area and just export it to your drive. What is this? This is the raster. DAM is raster file, na? So here the mask max mask is what? It stores the image in raster format. So first of all, I have to convert into vector polygons format. So reduce vector is used here to just convert raster into vector. Then again, reducer, e-reducer. Okay, applied. Then geometry, lake boundary. Geometry is what? Lake boundary. Again, a scale is 30 meter. Why I'm taking 30 meter only here? Why I'm taking again and again 30 meter? Why not 10 meter? Why not 20 meter?
Because the resolution of Landsat 7 is 30 meters.
Yes, right. Fine. Fine. Because the resolution of Landsat 7 is 30 meters. So you cannot take 10 meter. See? Okay. The maximum pixel is also same here. One is 13. And the geometry type is what? Polygon, and the label property is called water. See? Okay. Description is written here. You can write anything. File format is .save file, and the folder you can just write here according to your bill. Okay, as per your Google Drive. Okay. Till now, is there any problem to you?
No, sir.
No? Fine. And the next part is coming group year by year for calculate maximum area. Okay. See, in this part, actually a group has to be created, is being created area by year. A group is created in which what is stored? It stored the maximum area of each year. Okay. It is storing the maximum area of each year. Fine. That is group year and calculate maximum area. Similarly, okay, fine. In which what I have done, area by year variable is created. This is a feature collection in which the images are from 2002 to 2024. Okay. Then year, what is this year? Number, Earth engine number. It is a function of Earth engine that is calculated. That estimates the year. Okay. Then filter what? Year, each year in which the year we have provided in the upper part of the code. And then maximum area is what? Aggregate maximum area in meter square, that already have calculated. Okay. Okay, fine. Till here. Then I want to know maximum area is calculated, maximum area is stored per year. I want to know just what is the annual area change of that lake. So, okay. And now, first of all, you tell me why it is important. How can it help in your analysis? Annual area change. How can it is how I help to you? Annual area change. I have calculated maximum area. I have calculated maximum
understand the increasing or decreasing extent of the layer.
Yes, you can visualize, you can study how what is the trend of the area change in that lake. Okay. These things are very important before studying any glacier lake, to just come in to any decision like this lake is vulnerable to disasters, or vulnerable to blow, or it will do any disasters like things in near future or far future. Okay, these things are very important. So that's why I have calculated the annual area change. Okay, then first there is a variable defined here, variable years, in which there is a list of years, and variable areas in which there is a list of maximum area per year. Okay, you can see here in this list. Okay, so and then I have what done. There is another variable, that is variable annual change. Okay, then it will just do simple mathematics. It will just calculate, it will just subtract the area, maximum area between the two subsequent years. Okay, fine. Annual change is what? Annual change to just subtract the previous year to the next area, next year area. Okay, maximum area. Please just keep in mind, it is doing everything with maximum area of lake. Okay, there are so many area in the year now, it will change like that. Because I want to just study, because maximum things are showing what we can just going towards the maximum extent of the area, because we can take average area also, but maximum thing shows what we just if we have done the analysis of maximum area, then we can say that the it cannot go up to this. Okay, like that. So fine.
Fine, sir.
Okay, then the next one is chart. It you can see here, you will run the I think you don't have run the code in your systems. When you will run the code, a chart will be generated like that. Here you can see. I will run again here. You will see the chart here. I will explain this chart also. So in this part, in the chart part, we have just taken the area chart. UI, this is the function of the in the Earth engine. What the feature have taken annual change. Property year is written here. What you want to written here? No, year is what? Here written a year. Okay, this is year. Then maximum area, maximum area in kilometer square and aerial change in kilometer square. Then chart type is combo chart and the set option like title. What is the title of the chart? Okay. Then series. How can you can just adjust this series 0 type which type of this bars. You can just line. You can just write light line also. So I have defined the maximum area with bars and the annual change with line. So you can change the difference. You can see here also. The bar shows the maximum area of annual maximum area of each year and the line shows annual area change. Fine. And then print area chart to show here in the console. I've just printed the area chart into console in the console. And the last one is this. I have exported the annual change or annual area change and the maximum area to as a CSV. So you can just get in the format of CSV also. Here you can see everything. You can see here that everything is happening, but you want the data. You want the data, numerical data, to just do the analysis in in the Glock modeling, in the Glacier Lake auto flood, Glacier Lake analysis. Okay, you want the data, na? You can see everything here, but what to do now? What to do next? You want the data. You actually want the data in the number format, like in the Excel sheet format or in the Word format, in the table format like that. Now there are so many options here. So that's why I've exported the annual area change and the maximum area of each year in the form of CSV format. Okay, so you can see here in the task. See here, one thing also exported. One thing is that South Lanong Lake overall maximum extent. One thing is that there is maximum water extent as save file, and the second one is that that have the maximum area of each year and the annual change of the each year between each year. Okay, you will get the two important data sets here, which you are able to export in your Google Drive. Okay, then you can in your systems. See, okay. So till now I have exported, I have just explained the entire part of the code. I am running again here to just show you and to export the after show how to export the results. However, you got the idea of how to exporting the results. I have just clicked on the run again. You can see here. So it ran and you can see here it shows what maximum area in meter square is that. And the maximum area comes in which year? In 2003. You can get the results here also, na? You can see here. Fine. Are you getting the point?
Yes, sir.
Yes. So
yes, sir.
Maximum area is what? 664,699, I think. And the maximum year in which the maximum area came, 2003. Okay. And here the chart is generating. Okay. It will take time. And in the meanwhile, you can go to the task. You can see here the two unsubmitted task is showing here. You can just run here and you can just download and export into drives. I am exporting all the things in your in the drive. I am clicking the run first of all the CSV file. Okay, gexport is no any folder in my drive. So okay, if you just okay, I want to show here one thing. I have click on run. Fine. Here a drive folder gexports. Okay, if the drive folder exists in your Google Drive, you can just keep as it is. If the drive folder with this name is not available in your drive, if you just delete this, it will just automatically go to the drive main window in the drive. Okay, in the home page of the drive. Otherwise, you can create a new folder also. Okay, so I'm exporting here and clicking run. I want to just export in the home file. No issue. It will started. It is started. The code is started running, and it will just export the CSV file to my drive. And similarly, I will export the maximum water extent in the save file format. in the save file format. I've exported both these things, and I can see here after final export, the export is completed. I can see in my drive and download in my local system. Okay, you can see here the chart is created now. See, okay. If you want to just visualize this in a bigger screen, you can just click here. You can see here. Okay, just click in the corner, top corner window. Click here. It will open in the new window where you can see the. Okay, here you can download. Here it gives the option to download this chart in different formats. Okay, you can download a CSV from here also. You can download a SVJ, you can download a PNG. I'm clicking to download a PNG. See, it is downloaded in my system as a chart. Okay, the same chart is downloaded in my system. I'm opening here. Okay. The chart is downloaded now in my system in the image format. Fine. You can see here in my system. This is not in Earth Engine. I have downloaded it in my system, the complete chart, the same chart. Okay. So here you can see in the bigger window, you can download a CSV from also, you can download SVG from also here also. There are different types of formats here in which you can download this chart. Okay. So I will go to the task. It is both the task has been completed. I will go to my drive. See, in the first one is showing, na? First is showing Google South Long Maximum Area. Okay, I have to click and download there. I click and download this CSV to my system. It is downloaded now. Yes. It is downloaded now. I will open this CSV file. See, here there are different types of column. Are you all following these things? Are you all? Here in the CS file, I have downloaded the CS file from my drive. Here there are different columns. Here there is area change in kilometer square, and this is the maximum area column in kilometer square, and this is the year. Okay. Fine. This is the maximum year. In the CSV file, you can get these results. The other one is save file. Imran sir, please mute yourself.
Sir, I have one question.
Yes, please.
Sir, if we change the shape file to the catchment level, will it map all the glacier lakes in that catchment?
Yes, it will just calculate the water body. It will calculate individual wise what? It is calculating, it is estimating the water index. So the total number of water bodies available in your catchment, it will calculate all the individual for all the lakes. Okay.
So it will cover also the river flow.
Yes.
Okay, sir.
Okay. Till now, I've shown the code. I have just shown how to download the CSV file, how to just show the chart. Everything I have just demonstrated. Please, first of all, I want to show the save file. एक्सपोर्ट तो कर दिया सर ये पेन ड्राइव से कर लेते हैं
लोकेशन तो नहीं हटा दिया था, जी एक्सपोर्ट हटा दिया।
तो ये मैं मेन विंडो पे लेके आया था इसलिए इसको।
My right, my right. जी एक्सपोर्ट कर दो।
अच्छा बना लिया है क्या ये? नहीं इसमें एक बार और कर लेते हैं, चला लेते हैं, जी एक्सपोर्ट में कर लेते हैं।
पहले वाला तो
ये ओवरऑल एक्सटेंट इसमें डालते हैं इसको। So till CSB it is not, is there any issue to issue to anyone till CSB? No. So I am just showing the shape file also, and then here you can see the overall maximum extent shape file is also exported in my drive. Now I'm going to download this first. Yes.
सारी शेप वाले उसके एसोसिएटेड फाइल आएंगी तो कोड सब भी डाउनलोड करना पड़ेगा। ये सिर्फ डीबीएल फाइल आएगी,
एक्सेप्ट करना पड़ेगा ना, अभी नहीं आया ना शेप फाइल। See here in the when you will export the shape file, it will have different types of formatting. Okay. Your question is what?
मैंने देखा डेटा सेट इज मिसिंग।
चैट कहाँ पे है? एक मिनट चला गया। चैट कहाँ चला गया सर? हाँ सर some data some कौन से Madhurima ma'am, but in my CSV you can see here each area data is coming now. Have you run your code in your system? Yes, sir. Okay. First of all, let me show you the shape file. I think there is a problem with your system histogram and CSV file also. Hello.
Sir, please mute your mic. Your mic is creating a problem in the training session.
Here you can see I have downloaded the save file. Okay, so I am opening in QGIS. Okay, this is the give this save file gives the maximum water extent. With the help of this, you can just just create the lake boundary with the maximum water extent. Okay. I think not continuous. Maybe it has a I think there is a problem with the boundary, but you can see here, you can just take the idea of this, like the study of this lake I have done here. You can get the maximum water extent of that area, the line of the maximum water extent of this lake. Okay, here by using the save file. Imran sir, please mute yourself. Fine, you have got the idea of this. I will give you the. I will check again the save file, but it is not continuous. I will just check this and give you the updated code to you when we will supply the code to you with the full description. So there is no problem. But I think I just want to know, just you all have got the idea of the lake mapping, of the glacier lake mapping, how it can, how we can do this, why it is important, what the main results that we should have in the lake mapping. Okay, all of you got the idea?
Yes, sir. Yes, sir.
Yes. Okay.
Yes,
so now what will you do? You just run the same code, in your system with the same save file first, and then run the same code with the save file with your own interest. Okay, if you have save file of any lake with you, you can run this with different time period. Okay, I am running this code. First of all, I want to show you one thing. Here I am running this code between 2020 to 2025. Okay, for 5 years only. Here it can do. Here it can also. Okay, na. I am running this code for 5 years only. इस दिखाना चाहिए 20 तारीख का नहीं लेकिन 24 तक ही अच्छा ओके 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 डेटा से अपडेटेड 7 को जनवरी ठीक है 24 तक मतलब 23 तक ही ठीक है 23 तक तो फिर पीछे से करते हैं थोड़ा प्लान से डेट 7 की जगह लेट रिप्लेस चलिए ठीक है वो तो चेंज करने की चीज़ है वो देख लेंगे बाद में. So this Landsat 7 image is available till 2023. Okay. So first of all, you just what I have told you earlier, that's run this code with the same save file with the you can just take the same year period, same time period 2025, and just change the date and run the code again, and then change the save file. Change the save file of on your own area. Okay, change the save file of your own area, and then again run the code. Okay, everyone, please. इसको दोनों को पेंट से बाउंड थ्री एलिमेंट्स चलिए तो चेंज करूंगा बाद में बैंड सेट का देख रहा था सर मैं बैंड सेम रहेगा ना बैंड इसमें डिफरेंट है
नहीं सर बैंड से चेंज हो जाएगा 4 और 4 हो जाएगा बस रॉ पिक पे कर नहीं 5 पे
ठीक है ना एवरीवन। इसमें देखिए एक चीज है कि अभी जो दिस थिंग वन थिंग इज देयर दैट the Landsat 7 image is I am told earlier that you have to choose the image according to the study period in which you want to study. Okay, so the Landsat 7 image available is till 2023. If you want to just do analysis after this, so maybe that's why some of the areas is not coming after 2023. Okay, so if you want to study after 2023, just change the image. Just
LC08, C08, T18. What is the
same है ना? अच्छा LC08. ठीक है ना?
ईयर बदल 2014
14 चेंज करूंगा चलते हैं चलते हैं नो फीचर्स कंटिन्यू नॉन
3 और 5 बैंड कॉम्बिनेशन 3 और 5
3 और 5 अभी तक फंड लगा ठीक है
क्लाउड वाइज
non-feature content, non-values of fear, no feature content. Charting. Okay.
So do we have another after this?
नहीं सर कुछ नहीं पूछ रहे हो अपने कुछ बोल रहे हो ओके अब ये देख सकते हैं you can see here in the initial code that I have given you I have just taken Landsat 7 because I want to study from the 2000 to 2025 or we can say that 2020 to 23. Now I have just in this code that is showing in the screen. Okay, here I have told you now that according to your time period you can change the image. Okay, now I have changed the time period to 2013 to 2025. Okay, so I have now taken Landsat 8 image because Landsat 7 is available till 2023. Okay, so you can see here Landsat 8 image giving the complete result here. Okay, fine. So I hope you all got the idea about the things. Okay, so first of all, you will change if you just change that time period, you will change the image, and then carefully you have to see the bands available in this. Okay, because green band and NIR band, you for NDWI you have to take the green band and NIR band. So accordingly, the band name is different in different images. So accordingly, we'll choose the band name here. See, okay. Band 2 in Landsat 7, band 2 is green, but in Landsat 8, band 4, band 5 may be the green band. Okay, so that's why you have to choose the band according to the image. Fine. Fine till here. Have you all run the code in your systems? Okay. The new code is also shared in the chat box. You can check this. हाँ ठीक है कोई ठीक है सर इतना ही चल रहा है कोई कर लेंगे बाद में इसको 0.1 आसपास है वो तो मैं बस दिखाने के लिए लिख दिया था एनालिसिस तो कुछ किया हमने इसमें ठीक है यहाँ तक एक चीज मैं दिखाने ये चाह रहा था 2020 से 25 के बीच में इसको रन करते हैं 24 में आ रहा हूँ इस बार 23 में तो लेफ्ट टूटा है 24 में 24 में आएंगे ना एरिया बढ़ रहा है मतलब फिर से एरिया 21 2020 से अगर देखें तो एरिया इंक्रीज हो रहा है melting हो रही है तो साथ लेना है so you can see here we have just shown the code here from 2000 to 2025 and 2013 to 2025, and here I've taken the date 2020 to 2025. So you can check the shorter time period also, na? So you can see in the larger time period you are not able. You can just analyze or in the larger time period also, but you can directly see that in between the 5 year the lake area is continuously increasing. Okay, this is the result of South Lenong Lake. I hope you have all aware about the South Lenong Lake. The lake that Globe event happened due to landslide in 2023, and still the area of that lake is increasing because melting is occurring. Okay, so you can see also here that the area is increasing from 2022 to 2024. Fine. So in this way, you can just understand the importance of this study, in the importance of this lake mapping. What is the importance of this lake? I mean, how can we analyze any lake by using these maps? Okay, by using the data assets in the CSV format, you can just export the data sets in CSV format. Just further, you can just use the data per year to calculate the maximum volume. There are so many those who have involved in the GLOF study. There are so many empirical equations like Hegel's and all to use to calculate the maximum volume by using the maximum area of the lake. Okay, so you have I hope you have all got the idea about what is lake mapping, how to do this. I have just shown you the lake mapping by using two different images for two different time periods. One is for Landsat 7, one is for Landsat 8, and I have shown you how to export the charts, how to export the save file of the lake, how to export the data of maximum area in CSV format. So these are the things which can be helpful for any glacier lake study. So now you please run both the codes with different images for the same area that we have given in the code and the different area. Now there will be the hands-on session for the half an hour, and you will just run the code. Everyone more or less will show the results in the form of charts of that area in the WhatsApp. Okay. Change the area. Okay. Then if first of all you will just run, you will just run the code with the given save file, and then you will change the save file. You will change that save file, and then you will run again the both code. Okay, and then everyone will send this chart image. Just run for the 4 or 5 years, no problem. Just give the chart of your area in the WhatsApp. Okay, because now there will be hands-on till for half an hour. Okay, we are here. If any doubt, you can ask directly, but just try to run the code. Okay, complete code for this area and also for your area, and just estimate this chart and send in the WhatsApp. Everyone, please. Okay, everyone, please. Say yes. Respond, please.
Yes, sir.
Okay. Just do the analysis. This is very simple, no problem. You have to just change the save file only. If you have save file uploaded in your Earth Engine asset, no problem. If it's not uploaded in the Earth Engine asset, you can just upload. Or if you don't want to just upload, just create the geometry here and just do the analysis for that geometry. Okay. You can create the geometry here, na? AOI. You can create the AOI here directly. But try to choose the lake of any mountainous region.
You can even use the hand tool and select this AOI and keep it at some
other place. Yes, yes.
Then even change the lake. Suppose I want to estimate for this lake.
Yes, you can do also.
And then
this also.
Run the code.
Yes, you can do this also. Don't go to the uploading, just creating the save file and uploading to the set and do the analysis. It will take time. Just do this.
Use this hand tool and
Calculate the.
And please in the WhatsApp, please share your result.
Please share your result in the WhatsApp group.
Share this table, share this chart in the WhatsApp.
Run both the code. Run both the code for different time period. Okay.
How can we clip shapefile only for lake area and particular location?
See, for any particular watershed, you can take the MG Hydro tool that the session have happened yesterday. You just have to keep with yourself that outlet of the watershed. Okay, you can delineate the watershed, or there are so many options. You can use the hydro sets save file also. If you have delineated the watershed in the ArcGIS, then you can do also this thing, this also. And the other thing is that how can create the save file? You can directly go to the Google map. You can there create the save file of your lake. Just go to the Google Earth Pro. Just create the arbitrary save file of your lake.
Go ahead.
See, I'm going. If you just if we have the data of any lake, you just know the lake name. Okay, simply type in the search tab. For example, I am showing the example of this lake only. Like I have just type here South Lehnong Lake. South Lehnong Lake, Sikkim. It can be shown here, na? See, just click on this. You will directly and click search. It will take to you to the lake. Okay, if you just know the location of the lake, the name of the lake, you can do this. Directly zoom it. You can see here there is South Lehnong Lake. Do one thing. You can see now there is the. You can see the lake location. You can see the lake boundary also here. Just select this. Just select this icon, that is add path. Okay, add path. It will open a new window. You can just give name anything. I just take the untitled path and keep open this and start drawing the boundary of the lake like that, like that. You can draw the polygon. Try to just try to map. I have just drawn the arbitrarily map. Try to map this precisely by zooming in. Okay, now you can see the boundary of the lake is generated now. Now click OK. Now here you can see a lake boundary generated, but in the untitled part, you just save this, save place as KML. And in the GIS, you can save the KML as save file also. I have just saved this. I just kept the name Rohnak Lake. Okay, Rohnak Lake and click save. Now you can see here in my downloads, Rohnak Lake is saved in the KML file. When you will click this, automatically it will open in Earth Pro if Google Earth Pro is installed in your system. But it is KML file. Okay, if you want to export it save file, you have to use any GIS software like QGIS and ArcGIS. Yes, I have opened the QGIS already. And now I want to just convert this KML into save file. If you want to just import asset in Earth Engine as a save file, you just click on layer. First of all, you click on vector, then KML tools, import KML or KMZ. Go to the KML file that you have downloaded. Here you can get, I've saved this with Lonak Lake. I opened this. Okay, and click on run first. Okay, now the KML file is opened now. Okay, here. It is open now. If you want to save this as save file, you click on this export, save feature as easily save file. Okay, you can just give name to the save file anywhere you want to save. For example, I'm saving this on desktop. Save this. Okay, then it will save in the save file format. You can see here na .shp. Okay, now click on OK. And this save file is generated now. You can see in my desktop. Here you can see the save file saved here. Now you can directly export this save file to asset in Earth Engine. Fine. In this thing, is there any issue? How to generate the lake boundary or the watershed? Okay. So do your task. Don't go in importing and importing save file to asset. Just drag this save file to anywhere else and calculate the area and generate this chart. Okay, for that area, for lake area. Okay. And send the generated chart to the WhatsApp group. Each of everyone, please. फाइन हो रहा है सबका कोई प्रॉब्लम अच्छा आ रहा है फाइन Swapnil West fine Lonak Lake Sikkim Biplav one of the lakes from Arunachal Pradesh fine Ravi Kumar Sahu which lake is this is same lake like this okay Rakesh same lake कलर बदल गया ठीक है मतलब Madhurima ma'am fine okay till now 1 2 3 4 5 6 only 6 images बस हो गए 1 2 3 4 5 6 7 8 10 ठीक 10 11 हो गया 11 okay 11 fine good you are doing good job please if you have any problem please ask 75 participants come on. Each one of you will sharing chat बंद कर देते हैं ना Forwarded. Forward. Everyone, please do analysis.
Do
Forward others work. Okay. Each of one will give the two images. One is for the same area, one is for other area. So 75 participants are online now. So I expect 150 images. What is this? Swapnil list? Max lake event, maximum lake. Threshold and that's 15. Swapnil sir, please send the chart also. Swapnil Vist sir.
There is one question how to calculate catchment area at a place. So to calculate catchment area, you just type ROI dot area. The print ROI dot area. That will give you the area in square meter. Then you can divide it with 10 to the power 6. It will give you in square kilometer. And if you have uploaded a shapefile of a catchment, then you have to type AOI dot geometry, then dot area. If it is a rectangular box, then AOI dot area will work. If it is not in a rectangular box, then you have to type dot geometry and then dot area.
Swapnil Vist sir, if you have a question like if you could quickly repeat for Landsat and the change in bands. Yes. In the previous code, I have just taken the Landsat 7 band, and the same is can you see you can see in the search tab of the Earth Engine. So if you want to take the Landsat 8, just take the click the Landsat image in the search tab, and you can calculate. You can just check the bands available in the Landsat 8. Okay, and then you take the band which is green and which is NIR and the same name that shows green and NIR, and accordingly you can use the Landsat image. Okay. Bathymetric and volume of lake. Bathymetric is quite different thing. You can calculate the volume of the lake by using the area you have calculated now. You have calculated the area. So now just take, I have told you earlier also that there is so many empirical equations like Huggles, Evans, which gives the volume of area, which by using this empirical equation, you can calculate the volume of area by using the, volume of lake by using the area of lake. Okay. Rahul Thapa sir. Calculating bathymetrics is quite different thing, but you can calculate the volume of the lake here. Right, in the Earth Engine, you can also in the same coding snippet, you can calculate the maximum area by applying that formula. It is simple formula only. You calculated the maximum area. You just apply the volume formula there. You calculate the maximum area, volume of the lake also for each year. In the same way. So how many of you have the idea of the glacier lakes and glacier lake mapping, or how many of you are working in this area? Glacier lake mapping and all, glacier lake outburst flood, volumetric analysis, bathymetric analysis of lake. How many of you, please? No one?
No one? No one? Sorry. Okay.
Is there anyone who is working in this field? I am in first year of PhD, so I'm... Okay, okay. Try to work in this field. What's up, sure.
Please everyone turn on your camera. We will have a group photo. Hello Ritik, I am also planning to work in this group 9.
Okay. I'm first year graduate. I'm also at work, sir, in this field. Fine.
So I could see there are 104 people have registered online, but not all are attending the session. So I am getting the recording from the recording reports. I can get to know okay, how many of you are attending at for how many duration. So the certificates will be only to those people will be given only to those people who are attending it seriously. So please remember to attend it. Attending is very important. Later on, we will be sharing the recording also. We have requested the recording for yesterday's session also. But today our admin staff is on leave. So he will be sharing it tomorrow. The yesterday's session and today's session also. I have requested to share both of them. Okay, group photo, smile. Please smile for group photo. Okay. Yeah, nice. Change.
So have you all are able to run the code that we have gone through today? Both the codes?
Yes.
All of you?
Actually,
Yes, yes.
we also know that like this 5 day or 2 day is not enough for the session to learn entire coding. And if someone of you who are a very beginner in this field, they might find it a bit difficult to start. But I hope you are getting some idea that this kind of work we are able to do using this Google Earth Engine, and rest you can explore yourself also. Like I am also still learning how the things are changing with Google Earth Engine. They are also updating the script. They are also updating the methodology. They are also updating the imageries. So with time, everything is changing. So we are also in a learning stage only. And right now, we all know that there are a lot of AI agents are there like ChatGPT, DeepSeek, Grok. So you can even take the help from those agents, and you can simply give them a good prompt, like give me a code to estimate the area of a lake from this much area to this much area using Landsat imagery and in Google Earth Engine JavaScript. If you write this much description, that AI will also generate a code for you. So now code writing is not very difficult in current scenario. Only you get to know, you should know the essence. Is it doing it correctly or not? The result which is coming, is it correct or not? Only the validation thing you have to keep in mind. Coding is now into today's scenario, it has been taken up by the AI agent. So don't worry if you are not getting every line of code. There might be something which we are also unable to explain it to you. but you can take the help of some agents also, and it will also explain you ki, okay, what this line is doing, what is the difference, how this line is creating the difference. So उनके भी आप लोग you try to take the help from those agents also. And just our motive is that you should start working on this platform because it will save a lot of your time. Because downloading a single image and then processing it and then estimating NDVI in the raster calculator and then clipping it to your area of interest and then generating the report or generating the CSV. All these will take a lot of time if you are working with a traditional method. But now with using Google Earth Engine, all this part can be done on the system itself. As you could see, you are generating for different lakes, you are hardly taking 1 minute of time and you are generating the result. The only part remaining is the value which is coming, is it correct or not? The validation part is the thing which you have to work. Whether it is correct or not, you need to go to the field and verify, yes, if the area is coming correct or not. So the coding part and the processing part, all that has been already taken care of using agents, and also this code will take this code has solved the problem of all the data set pre-processing part. ठीक है. So the whole aim of our training course is to give you a glimpse of what this Google Earth Engine can do. In our later classes also, like tomorrow class also, we are having the flood mapping class. So you will get to know कि okay, you can use Google Earth Engine for flood mapping also. Like today you are mapping the water, and if you are doing the same thing during the flood time, that means you are getting the flood maps. And in that case, you also know that during flood, if there are optical images, then it will create a problem due to clouds. So we will be using SAR imagery, and we will try to estimate the flood maps and estimate the water area using that SAR imagery. So, and once the code is written, the code should be written only once. If it is written and if the code is working fine, only the change that you have to do is the region of interest. You just change the area of interest and your maps will be generated. So this is the beauty of Google Earth Engine as well as coding. So आपको मतलब I hope you all are getting the idea कि what this session was all organized for. So मतलब we were hoping कि everyone must have should attend, but we are seeing कि only 80 people, 75 people are attending on a serious note. But rest are maybe due to some their official work, they are not able to join. So for them, we are arranging the recordings. But for the certificate, I want to say like it is very important that you should attend it online, because we have to also give them give our headquarters the justification that we are giving certificate to only to them who are attending it seriously. And if you have any doubt, you can post it anytime in the chat box. WhatsApp is there. We will be not deleting that group. We will keep that group for our future sessions also. And if you have any doubt, if you are facing any time, you can DM us or you can DM in the group. And the people who are working on that code, they will only solve your problem. Okay, so just start practicing. This will take some time, but it is not very difficult. It is not very difficult. Just start practicing.
There is a question coming in the chat box like, shall we need to, for performing more on GH, shall we need to learn in depth Java programming? No.
Java say, listen, like my background is civil engineering. Like I have no idea of coding. During my bachelor, I had no idea of coding. During my master, I started learning Python. Even JavaScript, I also started a bit late. So it is not necessary that you know a very detail of Java programming in very depth. You try to learn only that much which is relevant to your area. If you are working on, suppose someone is working on forest fire. So you try to learn the JavaScript part of Google Earth Engine which is related to the forest fire, like indices which will give you the forest fire. Or if someone is working on flood, then try to learn that part only which will give you the flood maps. So it is not necessary to know each and every part, because even JavaScript is a huge, it is like an ocean. So we don't want that ocean to be there. We only want the part which is required. And you can use the agents that will surely help you in getting your images and processing your images. So there is no need of learning in-depth Java programming.
One has asked if I am using this code for entire water set, is it gonna give me the total outflow of that water set? No, this is not
No.
code for
It
outflow.
will not give you outflow. It will only give you the water area.
Water area
Water
only.
area.
It will not
Outflow
give
is
the
like it's a discharge, na, meter,
is discharge.
meter cube per second. So that is a bit different. That is called rainfall runoff modeling. So you are asking about runoff. It will not give information of runoff. It will give you the information of water area.
Yes, sir, getting, but today I am faced huge issue of my internet. Oh, fine. Just try to solve this from tomorrow.
Now the 5G connections are there, mobile, if you are 5G, you try to use the mobile data, don't rely on Wi-Fi. There any scope of internship opportunity to learn about? Yes, we do have internship opportunity. Our Indian Center as well as NIH is open for internship to the students, bachelor students, postgraduate students. You can simply drop an email that you want to pursue some, you want to do some internship, but that will be unpaid. So you have to take care of all the boarding, lodging and everything. But we will be providing you the.
Sir, internship can it be on a hybrid mode? It's like those who are working, can they do?
Actually, there is a system to take the attendance of the interns people. So hybrid,
Okay,
I'm not sure it is there. It will be there. I will confirm for that. In the hybrid mode, I will confirm. But since you can come, it is better that you come here and you work with us. We will give you a problem. You try to solve that problem, and then we can do. And minimum it should be of 3 month duration. Minimum 3 months, not less than that.
okay, sir. Thank you.
How accurate are tools like these days, like Cloud or GPT for coding? See, if you are using the pro version, so O3 mini model is very good. And if you are using on free, then I think Grok is good, and even DeepSeek is fine. They are good for coding. They are good for coding, but the result that is coming, you have to verify. Like whether it should not give some ambiguous result. Like if the total area is 100 and it should not give like 500 square kilometer or 500 area. That thing you have to take care of. Otherwise, these AI tools are very much advanced. They have already, ChatGPT has incorporated Stack Overflow. So it has it has very good coding database. It will give you we are using it. We are using it in our internal study, and it is working very good. We are even creating apps using those codes. So it is working. There is scope for internship also. Yes, there are scope for internship. So we have discussed AI also. And CA geography student apply for such internship. तो bachelor के लिए है. I will confirm. I think you can apply, but मतलब for all the application should be sent through your HOD to us, requesting for minimum 3 months of internship. But I am not sure about bachelor. Bachelor probably already. But we will confirm. We will confirm for the PA geography. Share the name of some AI platform for coding. ChatGPT, you might be aware. Then the DeepSeek is good. Then Grok, GROK, Grok by X, Twitter. Twitter wala Grok is also very good. It gives for Python also and for JavaScript. For both of the platforms, these are giving good results. And even there is one, I think extension has been, extension is also there for Google Earth Engine itself. They have integrated ChatGPT in Google Earth Engine, and you can directly code in Google Earth Engine. But it is in the development phase, and they have released the beta version, I believe. So that will also come in the later phase, that you can simply integrate Google Earth Engine with some ChatGPT, and you can simply write the code on the interface. In Landscape 7 around 200, there is an error images. Yes, you are right. There are swiping error. And so it is recommended to use Landscape 5 and Landscape 8. Try to avoid Landscape 7. Only use Landscape 7 after verifying whether there is no stripping error. So in our code, we have used Landscape 7 because it was there was no error for that region. For that region, the coverage was fine. Otherwise, if your area is big, it might create some issue. Could you please confirm about remote internship tool? I am in the US. Okay, I will confirm for the international students. I need to. I will confirm from the students. I want to learn about groundwater modeling. Is there internship with the PhD student? Yes, our headquarter has a groundwater division. So you can go to our website. I will share a screen. I will show you. In our day one lecture, I think Nima sir has told about our institute, NIH Roorkee. You can search for NIH Roorkee and you can check here for scientific division. There is one groundwater hydrology division. You can drop them email to the scientist and head or to any other scientist you feel. You can go to the workforce and you can check the name of the scientist and their area of interest. You can drop them email and they will reply. Okay. So we have a dedicated groundwater hydrology division. So you can contact them. And regarding the upcoming training also, like there is one column training activity and there is an upcoming training activities column. So you can refer we do conduct a lot of training. So this training is this one, which we are conducting here from 2nd June to 6th June, which is in the hybrid mode, but most of the sessions we are doing in the physical mode. So, and it depends upon your area of interest in which work you want to, in which area you are interested. There are a lot of internship, a lot of training programs that will be done. The modeling training part will be better done in a physical mode because you can resolve your query at every screen. But this Google Earth Engine can be taken care of in online mode. Random strip image issue can be raised by using no fill tool in QGIS. Yes, you can use that tool in QGIS, but for that you need imagery. You need to export every image from the Google Earth Engine to your QGIS. Then you can use that no fill tool in QGIS. Sir, HP in GE is possible. Yes, HP is possible in GE, but it is bit possible in the Python version, not in the JavaScript version. In JavaScript version, what you can do, like after getting the weights of each layer, you do the weighted sum here. But doing the HP itself could be taken care of by the Python part, not the JavaScript part. So HP is possible, but it is better to be done in Python, not in this. Yeah.
Okay.
Any other question? Like we are creating this in Google Earth engine only. We are creating a what also we are creating a repository. So in the last, I will even share this repository in which all the codes are there. So and I have also written all the I've given the comment what each line is doing. So I have added the comment also for each line, and I will be sharing this whole repository to you, so you can simply save it. But this will be shared at the last day. You all just please remind me to share that code in the group or anywhere. So I will be sharing all the codes. That will be really helpful. Small conferences paper can be easily done through this Google Earth Engine. Like simple single code, you analyze for 2-3 water area, and you can simply publish a conference paper. And if you are working for a larger area, if you take 10-20 watershed and analyze it very good, very correctly, then you can even publish some research paper on. So your writing part will be given more time, and analysis will be done very quickly. Will there be any hands-on session coding using Google Colab? No, we have not planned for Google Colab this time. Maybe in our next year session we will be doing some Colab practice also, or maybe in our winter session we can keep one session with Google Colab. Currently, we are working with JavaScript only because most of the things is solved in JavaScript itself. How we will extract precipitation temperature data from G for the precipitation and temperature data for every data set, as I told you in the first day. Like we have a data catalog, and each data catalog you can go through any of the data catalog which contains the precipitation data. And at the last of that catalog, a code is written to retrieve that data set. So you can simply copy that data set, you can paste it in some AI agent and ask him to extract, generate a chart for my area of interest. So it will write a code for you. So there are a lot of codes are also available. If required, I will share it to extract the precipitation temperature data. And there are some platform also there which are based on Google Earth Engine itself. Like we have Climate Engine website. That Climate Engine is based on Google Earth Engine REST API. So you can use that platform, and for your area of interest, you can simply generate the chart as well as the map, as well as the tip file, like chart and tip file for your area of interest, and you can easily get the long-term precipitation temperature data using that. The website name is Climate Engine. You can explore it. Okay, so that was all for today. Okay, so thank you, Chandra sir, for your
Thank you, sir.
lecture. We will be
Thank you, all of you.
you will be connected tomorrow also. No?
Yes, yes.
Okay. So tomorrow we are having session on flood extent, flood extent mapping, as well as
Sorry, images.
okay, as well as overview of flood vulnerability. We
Yes, yes. Remember the lecture.
Okay, okay. So let's meet tomorrow. So at what time we shall meet tomorrow? 2:30 or 2? 2 p.m. is fine for everyone. Okay, okay, okay. Let's wait. So 2:30. Someone said 2:30. Okay, we will try. Okay, we will try. We will start at 2:15. Okay, 2:15 is fine for everyone. Okay, okay, okay. 2:15 will be fine. 2:15 will be fine, and I will request for the recording also. By tomorrow, I believe we will get the recording for both the session. Okay, so that was all from our side. Thank you everyone.
Thank you so much, everyone.
Thank you, sir.
Okay, we will meet tomorrow.
Thank you, sir. Thank you.
Thank you, sir. Thank you.
Thank you.